Do you want to learn how to perform data manipulation and data analysis in Excel? If so, keep watching because this second session of the definitive guide to data analytics on Excel is for you. Hi, I'm Brian Amrine, co-founder and principal analytics consultant at Value Driven Analytics, and today, in addition to providing a brief overview of Excel, one of the most popular tools for analytics, we're bringing you not one, not two, but three analytics use cases performed right in Excel. First, we're going to build a personal finance Excel spreadsheet that you could use for your budget. Then we're going to do some analysis on a large data set of college football games. Finally, we'll get a sense of what it's like to use Excel for financial modeling for a company. I hope you're ready for a jam-packed session of learning Excel. You won't want to miss this session's halftime show. With that said, let's jump in and kick off with a quick overview of Excel. Welcome back to the second session of the Definitive Guide to Data Analytics, where I'll provide an introduction to Excel, one of the most popular tools for data analysis and data manipulation. Now, before we get started, I want to mention that similar to last time, this training session is covered and brought to you by Value Driven Analytics, your source for rigorous, fast, and affordable analytics consulting and transformation services. If you need analytics consulting, check us out at valuedrivenanalytics.com. With that said, let's jump in. You've at this point hopefully gotten through our Introduction to Analytics training series video where we provide an overview of analytics. So you're 1/7 of the way through, and now we get to talk about a really important tool, Excel. We're actually going to get into the tool today. But first thing we're going to do is cover last session's homework. I asked you to think about a few different ways that you could apply analytics to your company or your personal life. Let's talk about that. Let's also address some of the example requests that I provided last time. Hopefully you've had a chance to think about those. If you have, leave a comment with some of the potential ways to address those example requests. I'll provide some solutions, some different ways I would approach those potential requests, but keep in mind there could be multiple rigorous ways of addressing them. So I'd love to hear what you come up with as well. Then we'll do a brief introduction to Excel, similar to what we covered last time. And we're going to spend the majority of today's session actually in Excel working on 3 different use cases, really interesting use cases. The first one dealing with personal finance. We plan on creating a financial model that can track your expenses and your income and look at that over time, perhaps to plan out how you might achieve your savings goals. That is an example of using analytics in a way that can help you in your personal life, which is great. One of the benefits of being an analyst, right? Then we're going to take a look at a fascinating data set. It's 1 row per college football game going back quite a few years. And we're going to take a look at whether a team's regular season winning percentage can be used to predict the likelihood of them winning in the postseason. Really excited to look at that analysis, and then I imagine it will spur some ideas for further analysis on this really interesting data set. Then we'll take another use case that's similar to the personal finance use case, but applying it to an actual company in a way that an investment banker might take a recommended investment and use that to forecast what a company's income statement and balance sheet might look like if they pursued that recommendation versus not pursuing that recommendation. So something that could actually be used at a real company potentially. And then, similar to last time, you'll have the option to pursue a homework assignment specifically related to Excel. Some follow-ups to the 3 demos that we'll do today. So looking forward to getting into that with you. But before we go on and talk about our homework from last session, I was thinking maybe we could have training series t-shirts. Anybody who attends gets a t-shirt. Wouldn't that be cool? But then I started thinking about, well, it shouldn't just be for us. What about the analytics tools that work so hard for us day in and day out? Don't they deserve a t-shirt as well? And then that got me thinking, I wonder what size a spreadsheet wears. I got it. Excel. There's a little humor for you for today's training session. But yes, indeed, we won't have a t-shirt, but we do have plenty of jokes. There's more where that came from. Let's talk about last session's homework. Hopefully you've had some time to brainstorm some ways you can use analytics, not just at your organization, but even in your personal life. That's one of the benefits of being an analyst. The skills that you hone at work can also be used at home. Now, one of the ways that I've used that, and many others use those skills, is to create a personal finance worksheet where we can measure our income and our expenses, kind of plan that out, forecast that in the future, and then assess how we're doing against our budget, against our savings goals. Excel is a great platform for doing that because it's easy, as we'll see, to set some assumptions and then see how the result would change by changing that assumption. Update a cell and the whole thing updates automatically. So Excel is really good for planning out your budget. Another way that we're going to do today as well is analyzing your favorite sports team and seeing the quantitative side of the team you're used to watching on TV. Everybody has their own team, their own stats that they want to look into, and a knowledge of Python can help you pull that historical data and then also analyze it and to create this kind of statistics that you're looking into. I've even found, this is maybe less analytics related, but more of a way you can benefit from a robust knowledge of Python or other automation tools, that you can use it for regular computer tasks like moving a bunch of files or converting them over and over. I had a need where I needed to convert all these files to a certain format, and it was a very manual task, but was able to use Python to automate that. And then once you've automated that task, you can set it to loop over many files and accomplish what would be a multiple hour project manually. Not a very fun project, but especially the more you know Python, the quicker you'll be able to come to a solution. It can do all of that for you in a matter of seconds once you actually run the Python job. So that was a fun past personal project. And then periodically I like to come back and take a look at whether I can predict stock market returns based on historical price fluctuations, historical earnings releases, sometimes even looking at search trends related to that stock's brand, and see if any of those things can be used to predict what happens next with the stock's price. Now, on a particular stock, you're very unlikely to get a high level of accuracy, but perhaps when you buy a group of stocks, that on average you're able to come up with a prediction that is somewhat decent and maybe allows you to outperform the market. Now, there is an efficient market hypothesis out there that states that there's different levels, but different types of information is already baked into the stock price. So even if you model out based on all this historical data what you think is going to happen next, the efficient market hypothesis would say it's already baked in and there's no opportunity to get ahead of the market. We'll see if that's true or not. Maybe you can give it a shot. And if you're going to create a stock model, we'll get more into this in our data science modeling session. Make sure that it stands the test of time. Make sure that those trends that you find don't just apply to the time period that you trained it on especially, or even maybe the year or two after that, but does it stand the test of time, and year after year after year, this model you've created outperforms the overall market. That's hard to do, but it is extremely important to do that, because you will find cases where certain trends held for a time period and maybe multiple time periods, but then they fall apart eventually. So those are just a few ways that you could use analytics in your personal life. Now, last session we had 4 example requests that we covered, and I'd love to know in the comments section what kind of solution you came up with based on the tools and techniques we talked about last time. But right now, I'm going to share how I would typically approach each of these example requests. The first one was a stakeholder might ask, I'd like to have some visibility into how our sales are performing. Okay, well, one important thing to consider, just for starters, is what time period we're looking at. We might want to look at sales over the last day, over the last week, month, quarter. It just depends on what they're looking to do. Now, it's good to create, in this case, I would use an interactive dashboarding tool like Power BI or Tableau. But when you create that, it's good to bake in a lot of flexibility into it. So I would probably set up a dashboard that has the ability to see how sales have looked daily, weekly, monthly, quarterly, annually, perhaps even. And that might be a filter option to see what cadence do you want this broken down by. And I wouldn't just show it, for instance, if they chose daily, I wouldn't just show the data for the last day. They need to have some means of comparison, a baseline to compare it to. That could be what it was yesterday, what that day's information was last year. We talked about looking at things year over year for seasonality purposes, maybe both, or maybe the organization has a monthly, weekly, or daily goal, sometimes called AOP or annual operating plan, that we could compare against. So we don't just want to show for the last day what were sales. We need something to compare it to know whether that was a good day or a bad day. So I would tend to trend it out over time so that you do have history to compare it to. Definitely compare it to last year as well for a more seasonally adjusted comparison. And if the organization has a goal, I would compare it to that as well. Now, I'd also want to bake into it, especially if we're building it in an interactive dashboarding platform, well, why not bake in some interactivity to it? What if the organization wants to look at a particular geography and drill in and maybe even see, well, okay, we're doing okay. Where did we do well versus where did we maybe fall short? And so you might want to have an option to break down this sales reporting and the baseline we're comparing sales to, break that down by geography or maybe certain business segments, all kinds of things you could break that down by. I would make sure this dashboard has plenty of filters so that a user doesn't have to come back to the analyst to get a new view for a certain business segment or geography. It's all self-service. They can do that on their own. And maybe even some views. You can sometimes use parameters in a Tableau or Power BI dashboard to break down what that sales comparison looks like by certain business segments or by certain geographies. So hopefully that is helpful to one way that you can build a dashboard to satisfy this request and understand how sales are performing. All right, another good request here that we might get from a marketing stakeholder who would like to understand if geographic areas where we spend more on marketing typically see more sales. Now, when I look at this request, I see a target variable, something we are trying to explain in kind of a prescriptive way, and that is sales, and we have a hypothesis of a potential driver of sales, which is the amount we spend on marketing. Now, when I hear that, I automatically go to a data science model. And so what we might do is create a data set that is one row per geographic area. Now, the more granular you can get in general, the better read you can get. A model benefits from having a lot of different data points if it actually makes sense and those are truly unique data points. Sometimes when you're spending money, especially on commercials and such, a lot of times that's done at the DMA level, designated marketing area level. And so we might have a data set that's perhaps one row per DMA, and we may even have a data set where we can look at how much money was spent in a certain time period and what the sales were in that time period. Now, keeping in mind, we may want to look at something called a lag effect too. Maybe money spent in a certain time period, a certain month perhaps, maybe it doesn't automatically have an impact on sales that time period. Maybe it takes a few months in order to see the impact. So we'd want to consider that as we set up our model, maybe include some lag terms in terms of marketing spend. But setting up a model where we could look at how much money was spent in this time period, in this geographic area, and how does that impact sales could be a great way to do it. Now, there could be other things that are maybe correlated with marketing spend, the size of the area, the population of the area, demographic aspects, maybe other investments that the company is making at the same time it's investing in marketing that we may want to control for. Models, especially regression, for instance, allow us to control for other things. Now, this entire exercise of analyzing what the impact of marketing was on sales by looking at historical time periods and geographies where we've spent different amounts of money, this entire exercise is often called media mix modeling. It's quite a large industry. A lot of companies want to understand whether their marketing is actually making a difference and help them refine and understand where to invest more and where to invest less. So that would be the way I would approach it. Now, a very high level approach, wouldn't necessarily recommend it. It would be a little overly simplified, but it's something you could do, is perhaps if you took a data set that was one row per geography, maybe even one row per geography, year or month combination, you could just do a scatter plot where each data point is represented as a dot. Each geography or each geography time period combination represents a dot on a plot, and it is graphed based on the marketing spend in that time period in that geography on the x-axis and the amount of sales in that geography in that time period on the y-axis. And you're looking to see if there is a positive correlation, essentially. Now, there could be a lot of dots and it could be hard to see that. You could do a best fit line through it. A lot of dashboarding tools like Power BI and Tableau allow you to add that best fit line automatically, and it can give you an idea whether there's a high level correlation. But what it doesn't do is it won't automatically control for all these other factors that might be going on behind the scenes that you could if you're building a regression model in the first approach we talked about. The other thing that you might do as well is, rather than plotting what sales were and what marketing spend was, you could do kind of a change approach, which kind of controls for other factors about that particular geography. And your x-axis would actually be maybe the change in marketing, perhaps the year-over-year change in marketing for a particular geography, a particular year. The change in marketing spend for that area, for that year, compared to the change in sales in that geography in that year, and seeing if that change, if an increase in marketing spend in a particular area in a particular year is typically correlated with having higher sales in that particular geography in that particular year. So a change approach is another way you could do that. Lots of ways you could approach that. I'd love to hear about how you might approach this as well, so leave a comment if you've thought about this. This is an interesting one. We might have a sales manager come to us and say, today my sales team has about 1,000 customers for each salesperson in their territory that they could potentially visit. And each salesperson has their own way of determining when and which customers to visit and how often. But I feel like we should be able to give them some data-based recommendations. Is there any way that we can use analytics to help? Yes, sales manager, there certainly is. Now, a very basic way of doing this might be to just sort your customers by the amount of sales they've had recently or over the last year. Say, hey, we should probably be spending more time with the customers that do more business with us. And then as we have time, maybe we'll eventually get down to some of the customers that haven't done business with us. It's a very simple approach. It makes the assumption that our time is that we're actually, when we spend time with those higher volume customers, that we are indeed able to continue to generate incremental business with them. But at a certain point, that may or may not be the case. At a certain point, there could be diminishing returns. Maybe a salesperson's visiting an account so much that it's taking time away from their business. And so how can we figure out what that break point is? At what point should we move to the next customer on the list? Should it really be based on sales? And even if it were, again, at what point when would we make the time to visit maybe a customer who hasn't done any sales with us or has done less sales with us? Well, that's where a model that takes into account the incremental impact of a sales action, an email, a phone call, a visit, each of those have different costs associated with them. But what if you could build a model, and it would be based on the past, looking at when we've called, when we've visited, when we've emailed certain customers versus when we haven't, and understanding what was the incremental impact of that touch point. This is a great opportunity to use what are called interaction terms in a regression model. So we would want to understand, we have all these characteristics about the customer, maybe what business segment they're in, what geography they're in, when the last time they were called was. We're going to factor that in so we can understand diminishing returns, all kinds of things we know about the customer. And we would be looking at interactions between when that customer was called or emailed or visited, all different variables here. What was the impact of that on their sales, and then maybe the next month or 2 or 3. There are so many different ways you could set up this model, but I would say this is a great opportunity to build a response model. You build that model, and essentially you can run each customer through and say, what would my model predict that sales would be for this time period coming up if I called that customer today versus if I didn't call that customer today? If I visited that customer today versus if I didn't visit them today, if I emailed them today versus not. And what you would want to do after calculating that for each, this is all done automatically, applied to your whole data set through a tool like Python or SAS or R. For each customer now, you've calculated what that incremental likelihood or that incremental maybe profit that would be driven if you were to call them or visit them or email them would be. And you can rank order them by that. And that's a starting point for figuring out who you might call on that particular day. Now you've got to consider the cost side of it. Maybe for certain customers, the drive time could be higher. So you'd want to maybe consider that cost in the equation as well. And then how you route customers, right? If there's one that is, maybe there's a group of customers that you think would have a high incremental value of a call and they're close to each other. There's one out here. Maybe you save that one for the next day because it would just be a really big off-route drive time to get there. So many factors to consider, but I would start with that incremental sales model and then combine it with some kind of a perhaps geographical clustering model that could build an optimized route for it, and then bake in the cost of each of those touch points. So hopefully that's helpful. All right, how about this one? We might have a marketing stakeholder that asks us the following question. We're planning on launching a new online marketing campaign where we'll send a follow-up ad to visitors on our website. We'd like your help to analyze the campaign. Whew. It is a good thing they came to us before they launched the campaign, because that's exactly what needs to happen in order to set up an A/B test. And an A/B test is the perfect way to set up a measurement of what impact an initiative is having. In fact, if you go back to that request we had, especially around what the impact of marketing spend was in different areas, perhaps going forward, if it wasn't done in the past, there could be a random assignment. We are going to randomly select certain areas that we're going to spend either some amount or no amount, or perhaps spend more or less in, and then we'll measure the difference between the ones we spent more in and the geographies where we spent less in, and see what the difference in sales is. That would be the perfect way to determine what the impact of marketing spend is. And coming back to this particular scenario where we're thinking about sending up follow-up ads, that's great. There's a lot of platforms out there, digital platforms, that will allow you to do A/B testing, where you can take a group of visitors to your website and randomly assign a certain percentage of them to a test group where they would be sent follow-up ads, and then another group, the remaining group, that would not be sent follow-up ads, and that would be your control group. And at that point, the only thing that's different about them is the fact that the test group is getting follow-up ads, and that means that any difference in performance, conversion rate on your website between the test group and the control group can be attributed to the follow-up ad. So you figure out what that difference in sale rate is, multiply that by your profit from a sale, and then compare that to the cost of the follow-up ads, and you can really calculate a true ROI of the program. And if it's a good ROI and it makes sense, you can continue to do that and invest even more in that. You might start with a small amount of budget dedicated to this, see if it works based on this A/B test. If it does, now you can confidently roll that out and potentially continue to monitor it by having an ongoing holdout group. Just make sure that as you spend more and more, you're still getting that same or a satisfactory ROI on this campaign. So I would absolutely set this up as an A/B test. No questions about it. How about you? How would you set up this analysis? Let us know in the comment section. Well, I hope you enjoyed that sample analytics use case as much as I did. I just love coming up with analytics approaches. That's where the creativity in analytics comes in. Hopefully those creative juices are flowing right now. But anyway, let's talk about Excel at a high level before we actually get into the tool. This is a review from our last session. We talked about a lot of tools for data manipulation in the introduction to analytics session. Let's just do a quick review of the way that Excel is kind of differentiated among those tools. As we mentioned last time, Excel is essentially a set of worksheets, and a worksheet is a set of rows and columns that can have multiple tables potentially, multiple charts, and other visualizations. And one of the cool things about Microsoft, maybe a reason why it's so popular, is most organizations purchase an Excel license for their employees by default. It's often part of their Microsoft license. And it's been around for a long time. So there's a lot of people that are used to doing data analysis, data manipulation in Excel. And it is fairly flexible. But the biggest downside for me with Excel is that a lot of it is done manually by pointing and clicking. It can make Excel repetitive, sometimes inefficient, but on the other hand, it does make it really easy to learn, one of the easiest analytics tools to learn. One thing that can help with that some analysts invest in, is learning the language VBA, which can be used to create macros. And there's other advanced functions that can allow Excel to be automated to some extent. I've found that Excel tends to be the tool of choice for many financial analysts, oftentimes supply chain analysts as well, even some analysts that are focused on marketing and sales and other departments as well, and especially at analytics level maturity 1 organizations. Excel tends to be a really popular choice for data manipulation and data analysis. A lot of times when organizations are using Excel for reporting, they are emailing it out as a report, and sometimes before they get to that step of emailing it out, they're having to refresh it in various ways. Some could be as quick as just refreshing some pivots. In other cases, there's a lot of dragging and manually populating things and copying things. In some cases, hours of manipulation that has to happen in order to send out an Excel report, which is not ideal. Most of the time when it's sent out, the recipient has a limited ability to drill into data. So if they're seeing a particular trend, they're going to have to go back to the analyst and maybe ask, oh, wow, it looks like we're seeing a certain trend. Can you break this down for this geography or this business segment? And now the analyst is doing more manual work and sending that out, and there could be more follow-up questions after that. And that's the difference between Excel and doing your reporting and an interactive visualization tool like Power BI and Tableau, where if it's set up right, the stakeholder can drill into those trends on their own. That's self-service BI right there. And so a lot of organizations have gone that way. But Excel workbooks tend to also be used for quick data exploration and analysis. It is very quick to do a data manipulation there in a point and click way. So it can definitely makes sense to do that. And it's very useful as well when you have a situation where you have certain inputs or cells that you want to be able to change and see how it impacts the rest of the analysis just by changing a single cell. And you can do that with Excel, as we'll see in especially our personal finance and financial modeling use cases today. Excel is great for that. Now, it doesn't have much capability in terms of building data science models. There are some things you can do with certain add-ons. You can build a regression model, some statistical test, but it's not necessarily the most efficient way to do that, or especially when you want to refine and really go deep with your model. Excel is probably not the best tool for you. You want to use an advanced analytics tool like Python, R, or SAS. Now we're going to get into our first Excel demo. We're getting into Excel to build a spreadsheet that you can use to track your income and your expenses and forecast that out over time, perhaps to plan out your savings goals. I'm so excited to show this to you. It's a great example of how Excel can take certain inputs and you update those inputs and the whole rest of your model automatically updates. That's a way that Excel is particularly unique among all the analytics tools we're going to take a look at. So let's dive into Excel. All right, here we are in Excel. Hopefully you've been able to open it up, and we are in what's called an Excel workbook, and we're about to design our own personal finance workbook. Now within a workbook, there can be multiple worksheets. By default, one gets created called Sheet 1. We see that at the bottom. And if we want to rename that, we can simply right-click on it and then say Rename. And we'll call this one Budget. Give it a good intuitive name. And as you can see at the bottom, you can create multiple sheets within a workbook, multiple worksheets within a workbook. So here's another one, and we could rename these. I don't like to have any unnecessary tabs, so I will go ahead and delete these by, again, right-clicking on it, where you can rename, or in our case, delete. And that's a worksheet in Excel. Now what you'll also notice here is we have several different tabs at the top. Home screen has a lot of your frequently accessed things like the text color and highlighting, merging cells, all kinds of things. And we'll take a look at a few of these. But you also have the option to insert pivot tables and certain types of charts on the Insert tab here, drawing, page layout. One of the things that we will turn off eventually, we'll go ahead and turn it off now, is grid lines. Now this might be controversial. Some people like to have the grid lines. It provides some structure to the worksheet, but I tend to feel like it has a cleaner look without the grid lines. So I'm going to turn off the grid lines, and that is an example of a page layout option. Just uncheck that. Now you can see all those grid lines have gone away. Some people like them, some people don't. I think it gives it a cleaner look not to have them. Formulas, data, operations, we'll see some examples of this. You can review your work, do spell check, which is important because unlike PowerPoint and Word, Excel doesn't necessarily give you the red squiggly line when something is misspelled. So it's a good idea to perhaps use spell check at a certain point. And if I maybe did fruit and I misspelled it, and then I click on spelling here, I'll say, do you want to continue at the beginning of the sheet? Yes. And it finds that and it says make some suggestions here. So it's important to use that spell check. It will not give you that red squiggly line when a word is misspelled. So we can update it from there. Just one example of review functionality. View, now you can do some really neat things here, like freezing panes, so that when you scroll, a certain column will stay at the top or a certain row will stay at the top. Lots of neat things you can do there. And then you've got a automation tab. I haven't used this much, and then a help screen too. Now, something that'll be helpful in our case, as you can see, we're a little zoomed out and it's a little hard. It'll be a little hard to read the screen. So one thing I can do, I can either use my mouse scroller for this, or in the bottom right here we have a zoom option. I'm going to try to help you out and zoom in a little bit. There we go, that's a little better. And we can also take this formula bar here, which we'll eventually use to write formulas, and we will bring that up a little bit too, which will create some more space for us. But as we mentioned, this Excel workbook can be made up of multiple worksheets. In this case, it's one worksheet called budget, and a worksheet is a set of rows, which are based on numbers, and columns, which are identified by letters. And eventually, if you keep going and going, it starts to become 2 letters. So that's how Excel labels rows and columns. Now, we can have text, we can have data tables, we can have charts, all kinds of things. And you can put multiple of these things in a single worksheet. So there's lots of layers of organization, worksheets within workbooks, and then tables and charts within a worksheet. All right, so that's your very brief Excel overview, and we'll go over a lot of other functionality as we build our own budget and our personal finance workbook. So the first thing we're going to do is we might want to have an income section where we'll keep track of our different sources of income. And it's good to just generally label things. So to start out, I am just simply going to go to a cell, and you can just click on that cell. This would be cell B2, and I can either start here, or I can just even click on the cell. I can double click on it, and then you see the cursors there. We can even just click on the cell though and just start typing, and I'm going to type some letters, the word income. Simple as that. Now for us, there will be a couple of sources of income in our example. First one would be salary, so we'll make that its own row. Now notice I skipped some space here. Whether you're in Excel or any analytics platform, use spacing strategically. Just because we're analysts doesn't mean art or intuition goes out the window. No, we want to set things up to be aesthetically pleasing, and so if spacing helps organize things, use spacing. We'll do that here. Separate the section that we're in the income section, from the actual line items within the income section. So salaries are first one, and let's say we also have some savings, and perhaps it's invest in the stock market or bonds or some form of investment that we expect a return on those savings. So that'll be another row for us, return on savings. And let's say those are only 2 sources of income. Now you can customize this for your situation and have however many sources of income you have, and whatever those are, make a row for each one. Those will be our 2 for this example, and below that we'll simply type a total for them. So a total income. That'll eventually just be the sum of our salary and return on savings. And that's our very simple income section. Now, of course, the next part in our budget would be our planned expenses. And so we'll give that a title as well. Just call it simply expenses. Most people have rent or mortgage. And so we will, in this case, we'll call it mortgage. That'll be our first expense here. Might also have a car payment. Now we could go more granular. In some cases you might keep it high level and perhaps represent multiple car payments if you have multiple car payments in one car payment line item, or you might split it out for the individual cars. You can be as granular with your budget as you want to be, as you find it to be useful. In this case, we'll keep it high level and say we only have one car payment, or maybe we have multiple and they're going to be represented in the same line. So one line for car payment. Similar concept for utilities. We'll summarize all of our budgeted utilities in one line item, but you might separate it out for power and gas and all of that. All right, we'll also have a line for groceries. We'll also make a line for other. Everybody needs an other bucket. No matter how granular you get, you probably can't account for every single line item. That would probably be too complex of a budget, so you're always going to need some form of an other category, I think. Now, here's the thing about Excel. We've plotted out a few different categories so far. Let's say we missed a few that we want to put ahead of mortgage. For this example, let's say that we want to insert a row for taxes and maybe a row for giving as well. Well, one way to do that is to simply shift cells down. And so I would go to the cell where I want to put a cell above it, right above mortgage here, and I would right click on that cell and then say insert, and in this case I would want to shift the cells down one, and so I choose shift cells down, and now I have a new row here and I can type taxes. So that's one way of doing that. Now I want to show you a different way, but in order to show you that way I want to undo what I just did. Now this is where keyboard shortcuts can really save you some time. It's a good efficiency play to learn certain keyboard shortcuts, and there are a lot of them in Excel, but there's a few that I definitely recommend, and the one I'm about to tell you about applies not only to Excel but almost any application you use. You can use it for Power BI and many other applications. So what I did is I just inserted a cell, moved everything down. And what I'd like to do is undo that change. And so in order to do that, I'm going to type on my keyboard. I'm going to first hit Control, hit Z, and then let go of both keys. Control Z, let go. And it undid the change. Really neat. Now if you wanted to redo that, maybe you said, no, I kind of like that, having that cell there. You can do Control Y, let go. So Control Z to undo and Control Y to redo. Now I'm going to undo that because I want to show you another way of shifting cells. This is my preferred method for inserting cells. A lot of times if you want to move everything down on a row, in this case there's only one column here, so either method would work. But if you wanted to insert a row above everything, like let's say we had other columns that were populated like that, what I would do is highlight that row. Just click over here in the margin to highlight the entire row. And similarly, if you wanted to do this from a column perspective, you can just click on a column. So if I click on a cell, it does not highlight the whole thing, but if I click on a letter or a row's number, it highlights the entire thing. Click on that number, right click on it, insert, and there you go. You have a row, an entire row inserted into your Excel workbook. I'll delete these out. So we wanted to add a row for taxes. We also wanted to add a row. I'm going to add it right before mortgage. So I'm going to highlight row 11 that mortgage is on, right click, insert, and then type giving. Great. Well, that'll be our expenses for this example. And so at the bottom, I will also create a title for a total expenses row. Great. Well, we've got our salary, we've got our expenses. Now, one reason we might want to create this budget is because we'd like to plan out our savings goals. And so let's create another section for savings. So we'll start with the title Savings, and the first thing we'll do is create a category or a line item for savings. What were our savings this year? There might be a better title for this, but we'll call it just simply savings. What were our savings for this year? And then below that, we will create another row for savings balance. And that's going to factor what our savings were at the beginning of that year, and after the savings we plan on having for the current year, what do we anticipate our new end of year savings balance to be? That's what the savings balance row is intended to represent. All right, so those are our categories for this example, and next we are going to get into parameterizing our Excel workbook, where we'll have some inputs that will then feed into the rest of our spreadsheet. Well, we've got a great start for our budget. We have laid out our categories, but now we want to potentially insert some parameters at the top of our Excel workbook that we can update, and then those updates would automatically flow through to the rest of our budget. In order to do that, similar to before, we need to make some space at the top of our Excel worksheet here. I'm going to click on Income, and I'm going to create some room for parameters. So I right click on row 2, say Insert Cell. I'm going to insert another cell, and you can see it's a little repetitive what I'm doing. Now here's another method, and this works for whether you have blank cells like we have here and we want to create more blank cells, or if you have a particular section that's not blank and you want to copy it or cut it. You can highlight multiple rows, and likewise you can highlight multiple columns. Highlight multiple rows, and I can copy all of those and then click on the row I want to insert them into. Say Insert Copied Cells. And similarly, if I were to highlight all of those and say Cut, that is going to remove them from there. Once I insert them in a particular place, they are now removed. So that's the difference between copy and cut. I'm going to undo that by using the Control-Z shortcut. And there's also actually some redo options and undo options here if you don't want to use the shortcut, keyboard shortcut. Now what we're going to do is do that with the blank rows here to create even more space. So I'm going to highlight all 4 of these blank rows. I'm going to right click on them, say copy, and then I'm going to highlight on row 5, right click, say Insert Copied Cells. All right, now we're creating some space faster than just inserting rows one at a time. I might do that one more time. I'll probably create about 12 rows here at the top. Great, I've created some space. And now I want to lay out some parameters that are going to, high-level parameters that are going to impact our entire budget. I'm going to lay those out at the top of the code, or the worksheet. But this principle of laying out parameters at the top of our Excel workbook that then update everything else, it also applies to other analytics tools as well, like setting parameters in SQL or setting variables in Python, which we'll get into later on in these sessions. But let's set some parameters in Excel. So the first one we're going to set is our starting savings balance. Where were we at the beginning of the year? I'll make a row for that. We also need to set some kind of assumed interest rate or return rate. Rate of return would perhaps be a better word for it. Rate of return on savings. So I'll have a parameter for that. We also might want to make an assumption around salary growth. Certainly cannot be certain on what that's going to be, but we can make some reasonable assumptions, bake that into our model. We also need to consider what our tax rate is. And also what we have a line for giving. What's our giving going to be as a percentage of our income? So giving percentage. And we might want to think about for our expenses, we have an assumed salary growth. There could also, one reason why salaries generally increase is due to inflation, and that means our expenses might also go up. Certain expenses might go up over time, and so that can look different for each expense category, of course, but we will also try to bake in a general expense inflation rate as well, make some assumptions around that. So we have 6 different parameters that we're going to set at the top, so that if we want to make some assumptions and see how our budget would change if we experience a different inflation rate or a different rate of return on our savings, how that would impact our savings goals. All right, well, let's make some assumptions here. Let's say our starting savings balance is $50,000, and you can customize this as you wish. Let's say our rate of return on savings that we're going to assume for the next few years is, let's say, 4%. Adapt that to whatever your expectations are. Salary growth, 3% is a common number. Again, feel free to change these. Let's say that tax rate's going to depend on your income bracket, of course, but let's say our taxes, and this I guess would represent your national and state taxes, all of your anything applied to your income, including Social Security and those types of payroll taxes as well. Let's say it's 20% here, so we'll use that, and let's say we want to give 10% of our income, and let's set the inflation rate at say 4%. Feel free to adapt those as you wish. Now what you'll notice here is all the cells are equal width, all the columns are equal width by default. But one problem with that is the default is cutting off some of our titles here. Even down here, it seems to, it naturally flows into the next cell, but if the next cell is populated, it'll get cut off as it is here with our starting savings balance. So one option would be to say, oh, I want to expand that and kind of do that manually as I am right there. But another option, probably a better option, a quicker option, is to simply double click on the right side of that column, that column's letter at the top. So right here, you can see as soon as I hover on that edge, the mouse changes a little bit. I'm going to double click on the right edge of B in this case, and it automatically expands the column width to the longest number of characters in that particular column. In this case, it kind of managed to the rate of return of savings, and you can see added in a little extra there at the end, and you can adjust it from there if you wanted to manually. So that's a neat time saver, time trick. Now I'm also noticing here that the alignment is a little different. So Excel by default aligned everything to the right, which is fine. In this case, I might want to align everything to the left. So I can do this one at a time by highlighting a cell and then clicking the align left button here. Or I can highlight multiple cells at the same time and apply this to everything. And now everything's left aligned. So it's a little more efficient, is to highlight all the cells that you want to apply an operation to. Another example of that, it's good to use highlighting, not too often, not for no purpose at all, but strategically. And in this case, I want to highlight the parameters that could be updated that will update the rest of the budget. And so in this case, those are all up here. And so I'm going to highlight all of these. I'm going to use the same color. Some people might use different colors for certain things. Feel free to use color however it makes sense for your use case. But in this case, we can highlight everything, and there's this fill color, represents the background color of the cell. By default, it's yellow, and you could choose other colors if you wanted to, but I will use yellow in this case, or I could have just clicked here. And there you go. We've got highlighting. If we wanted to remove that, you could go to no fill. but we will highlight our cells yellow. And at this point, one more thing I wanted to add in here. I wanted to add in a starting salary assumption. And so in order to do that, I will go ahead and click on row 4. I want to insert a row above this, similar to what we did before. Right click on row 4, insert, and I will add a starting salary assumption, and we'll set that at 50,000 for our example. All right, we've got some starting parameters. Let's go into the next step and actually build out our budget. Let's build out our year-by-year budget. Well, when we build our budget, the year part will not just apply to one section. It doesn't just apply to income or expenses or our savings down here. It applies to all of those categories. And so rather than put a year into each individual category like income and expenses, let's just create one year label, and we'll do that at the very top of our budget area here. And our first year we'll start with is year 2023. I'm going to go ahead and put that in there. That looks pretty good. I might go ahead and center it here. Now, in some cases, perhaps if these have been drugged down, we might have a different format for it. And so if that does happen to you, you might right-click on the cell, and one of the options you'll have is to format cells. So notice this is just a general format. You have currency. Obviously that wouldn't look good for a cell, but I can right-click on it again and say maybe number. Sometimes you might see this and you might look at this and say, ooh, decimals for a year, that doesn't look right. Comma separator, which is generally a great thing to separate your larger numbers with a comma for every thousands, every 3 numbers. But doesn't make sense for a year. So right click on that, format cells, and we can either go back to general, or we could use number and just simply turn off the 1000 separator and reduce the number of decimals. Again, default was fine in this case, but if you do see that, that's how you can adjust formatting. Another format that you can see up here is to turn it into a percentage. Obviously that's not what we want in this case, but those are some of the more popular formats that get used, and that's how to change it. Just right click on the cell. I'm going to do Control Z to undo that change. But that's our year. So we've gotten our year, we've centered it. Now we are going to want to build a budget where we can forecast our savings and our savings balance over time. We can actually do quite a bit of planning here. So let's say that we want to extend this out for several years. Well, I could set this up where I populate 2024, and then I'm using the arrow keys here, but I could also just double click or click on any of the cells 2025. I'm doing this manually, but there's a better way. So another way to approach this is to say, well, each column I populate is simply one more than the previous cell. That's a great use case for an Excel formula. So instead of doing this, what I'm going to do is type equals, and you can see that simply overwrites what was there before. And now I can actually point to another cell. This is the beauty of Excel. I can point to this cell and it says whatever is in this cell, that's what I want to start with. And if this cell ever changes, this cell is linked to it and it will change too. It'll always reference whatever the value is in that cell it's pointing to. And cells are referenced based on their letter, the letter of the column, and the number of the row. So in this case, it's saying equals C12. And you can simply click on the particular cell that you want to reference. You can see the reference is updating here. But you can also just simply type in that reference if you look at it and know that. So either way works. Now in this case, we don't want it to just equal 2023. If I want to edit this, I'm going to just double click on it and it brings up the equal C12. But we want it to be whatever that year was plus 1. Great. All right, so I will drag this across, just make several years here. Maybe we'll go through, let's say 2032. Now, if we were said, how many years is that? A quick way to do that is to highlight. You can highlight columns, you can highlight rows, you can highlight combinations, a whole set of rows and columns. But one of the neat features here is that when you highlight rows, you get some summary statistics at the very bottom. This tells us the average among all populated values. The average here is 2028. Then it tells us the count. Now, this is not the count of cells per se, but it's the count of cells with a value in it. So notice the count is currently 10. We have 10 rows represented here. What happens if I went further out? I'm highlighting more than 10 columns right now. Notice the count's still 10. That's because the count only count, and notice the average hasn't changed. It didn't factor these in as zeros or anything like that. The average, the count, the sum, they are all based on purely populated rows. So this is saying there are 10 cells that are populated. And among those 10 cells that are populated, the average is 2028. I'm going to highlight all of these. And again, similar to what we did over here with the highlighting and the justification, I'm going to, in one go, apply centering to all of them. Now in this case, I also want to have the same column width for all of those. I want to keep things as consistent as possible. And so I'm going to highlight all of the columns up here. And then if I manually adjust the column width that I want, it is going to adjust all of the columns for each year so that they're all the same, whatever I've chosen. I'm just editing column C here, but I have everything highlighted, so it'll apply that formatting to everything. And now all the columns have the same width, which is a little more aesthetically pleasing than having different column widths. All right, so that is our year breakdown that applies to income, expenses, and savings. Now another thing I want to do here is take this income section, and I might want to expand the title for this to go all the way across to all of our years. So I'm going to highlight the cell that income is currently in, and I'm going to highlight all of the columns that represent different years, highlight all of those. And this is where the merge and center option comes in. I'm just going to highlight those, come up here and click merge and center, and there you go. Now our income title goes all the way across all of our years. So that looks good. Now this is the title, and so I'm going to maybe apply some bold formatting to it to make that title stand out even more. I might also put a border around it. Now you could use underline, which would just simply underline that text. It doesn't go all the way across. In this case, rather than do an underline that only goes for income, I want to make it clear that this applies to all of the years. And so instead of, I'm gonna just click underline, which will de-underline it in this case, and then I'm going to apply a border to it. Now you have thin borders and you have thick borders. In this case, we'll use a thick border. There we go. That looks pretty good. We can do the same thing with expenses. That's another category label, and so we will highlight all the cells here, click merge and center, click bold, click border, and there you go. It looks pretty similar. Now there's a faster way to do that. I'm going to do Control Z. You can do Control Z multiple times. That undid the border, that undid the bold, that undid the merge cells. I did Control Z 3 times there. Well, what if I said, well, I basically just want to do the same thing I just did to income. I want to apply that same formatting to expenses. One option for you, and this applies to a lot of scenarios, is to highlight the formatting that you want to apply. So I say, yeah, income looks great. If you could just take that formatting and apply it to expenses, would be great. Okay, highlight that. Click Format Painter here. And then you can see we change the border a little bit. It's kind of saying, okay, we're about to apply this formatting to whatever you click next. So after you click that format painter, the very next thing you need to do is click into the cell that you want to apply that formatting to. And it's the expenses cell right here. So watch what happens after I clicked format painter and then I click expenses. There you go. All three of those things, the merge cells, the bold, the border, it's all been applied. And so why not do that again? We can actually do it from expenses this time, or income. We're going to click on that formatting that we like, click format painter, click on savings. There we go. We've quickly created some similar formatting for each of our labels. And I might put some bold on all of the years by highlighting all of them, just trying to be as efficient as possible. It's taking shape. Well, let's try to populate our first line item here, which is salary. Now our starting salary, we could just go in and say, oh, it's going to be 50,000. But we created a parameter up here for a reason. We want to simply be able to point to the starting salary up here and be able to update at the top of our workbook and then let that flow into the budget from there. So rather than what this would be called hard coding down here, we have typed in specifically 50,000, and so if we update this to be 45,000, for instance, it doesn't change here. Well, we want to be able to just change these parameters up here and have everything flow through. So instead of hard coding it here and typing the specific number, we're going to use the equal sign and point to the cell C4. In this case, we can click on it. Great. Now watch what happens if we update this to 45,000. The cell updates too. Pretty neat. Very similar to what we did here, except in this case, we're just simply pointing to that value. We're not adding one like we did for the year. All right, so let's change this back to 50,000. Cell changes. Great. 2023 is really easy. Now in 2024, again, we have assumed that we will have a salary growth each year of 3%. So an easy way of calculating that would be to say, well, what was your salary last time? We'll point to 2023 salary, and then maybe we multiply by 1.03. You get your salary last year plus 3% in the next year, 2024. That's our assumption. And that would, oh, notice what happened here. It does this hashtags, multiple hashtags. It says there's not enough room to display this. Now there's a couple ways of handling this. One would be to expand it by going up to the column letter, double clicking on the right edge. There you go, it expands it. We can see all the numbers now. So what it did here was it actually put in some decimals here, which you don't want to show decimals unless it's really necessary. We're talking about something like a salary, especially one in the thousands. Probably don't need to see the cents there. It's just too much information. We want to simplify it a little more. And so one way of doing that would be to right click on it and say format cells. Okay, reduce the number of decimal places. And there you go, we're back to where we were before. And now we might want to update our cell headers. I'll just update that there. Okay, looks good. We did inadvertently though, we did some hard coding. Sure, our salary will update if we update 45,000, great. But if we update the salary growth to be, say, 2%, this doesn't change. Why? Because we've hard-coded this salary increase of 1.03 down here. So we want that to be dynamic and to reference this salary growth assumption up here as well. I'm going to do Control-Z to undo those. Okay, 50,000, 3%. So now instead of doing that, what we can do here, the multiplication sign, by the way, is this star. That's what's used for multiplication in Excel formulas. Well, I'm going to delete this 1.03. So we need it to be 1, because that represents what our baseline was, plus this 3%. So instead of putting 0.03 there, we're simply going to point to the salary growth row. And then we'll do close. So parentheses here, we need this 1 plus 0.03 in this case to be calculated before doing the multiplication. So we're using parentheses to handle the order of operations. All right, that should be good. Looks good. Now, if we update our salary growth to be a little bit lower, this number changes. So everything, and if this changes as well, similar to last time, it changes. So our salary numbers here are truly dynamically changing based on these parameters that are set at the top. That's what we want. All right, well, I guess at this point, similar to year, we can simply drag this. This is neat. You can, one way of doing this would be to right click and say copy, paste, and then maybe right click again and say copy, paste, and just kind of keep doing that. Now there is a keyboard shortcut. We can highlight something, Control C, and then you can paste it by using Control V. That's another good shortcut that works on a lot of different platforms. So either way, whether you right click on it and then right click on the cell you want to paste it in and say paste, either way we're copying, right? Now there is a quicker way to expand this though. In this case, we want to do that all the way across for 8 or 9 different cells here. What you can do in Excel is simply click on the cell that you want to copy over, and you notice the cursor changes a little bit when you go to the bottom right of that cell. That's good. You want to go to the bottom right of the cell, do a left click, and then drag. You can use this to drag down or to drag to the right or left or up. So we're going to drag to the right in this case. The whole thing is copied. Great. Now this is where a good sanity check comes in. We look at it and we say, oh, wait a minute, that doesn't look right. We're not seeing that 3% growth being applied to 2025 and beyond. It looks great for 2024, but what about 2025? One thing I like about Excel is if you double click into a cell, it'll highlight with colors what cells it's pointing to. So we can easily see, okay, it's pointing to the previous year times 1 plus 3%. That looks great. Well, what happened in 2025? Let's double click there. Okay, pointing to 51,500 from 2024. That makes sense. 1 plus D5. Wait a minute. That's blank. I don't want it to point to D5. I want it to point to C5. This is where locking cells comes in. So a way to, before we drag the formula over, in some cases, maybe you did have a different assumption for 2024. So maybe you said, yeah, 2024 salary growth there, I'm thinking 4%, and then maybe 2% after that. I'm gonna, get promoted in 2026, and then, I'm gonna do 3% after that, and now you actually have dynamic, a different salary growth for each year. So maybe you have some assumptions around this, and this is a good model for you. But in our assumption, we're going to have a simple assumption that just on average your salary growth is 3%. Okay. So in that case, we need to lock cells. So let's go into, before we drag in this, I'm going to highlight this and just click the delete button. That'll remove everything. Before I drag the formula, I need to lock any of the cells that I want to. Now, the 50,000 here, we do want that to always be the cell to the left. So that looked great. There's no locking necessary there. But we do for C5 here, you can lock the number, which would represent the row, or you can lock the column. In this case, it's shifting the column as we drag the formula to other columns. So we need to lock in the formula. We need to say we always want it to be column C, even if we've drug over to other columns. So let's do that. To do that, to lock either a column or a row, you simply put a $sign. And you can do that before the column, which locks in the column. And if you wanted to lock the row, you can do one or the other or both. You can put a $sign before the row number. In this case, we just want to lock in the column number C. So we've done that. We put the $sign in there. Watch what happens now when we go to the bottom right of the cell, drag it over. Okay, it's looking a little better. And we can see why if we double click. I'll double click on a different cell this time. It's still referencing the 3%. It doesn't keep shifting to the right because we put that $sign there. Now we wanted it to reference the most recent salary. We wanted that to kind of dynamically shift. If we go to 2030, it's referencing 2029. And so we didn't put the $sign in front of that so that it would drag over with it. Hopefully that does a good job of illustrating the difference there between locking formulas and not locking formulas. All right, we've got our salary populated. Now let's populate our return on savings that we expect for the next several years. We'll start with the first cell, and I'm going to go ahead and double click in there. Now this first cell is unique because we're not going to be referencing any kind of ending savings balance at the bottom of the sheet that would have been calculated. We will reference, at least for this first 2023 return on savings, what our starting savings balance was, the parameter that we enter at the top. So we'll reference that, and then we're going to multiply that by our expected rate of return on savings, which is the 4% here. All dynamically, so that if we update these later, it'll automatically update for our return on savings row. There we go, expecting $2,000 return, 4% of the $50,000 in 2023. Now for 2024 and beyond, our return on savings will be a function of not the starting savings balance for 2023, but whatever our ending savings balance was from the prior year, which will be represented in this row eventually. So we're going to point to prior year, 2023, C34 in this case, and we're going to multiply that by our rate of return on savings. Now let's not make the same mistake we did last time where we calculate that, we drag it over, and notice unless we wanted to populate a unique rate of return on savings for every single year, we need to lock in at least the rate of return on savings. Now, similar to what happened with salary, we do always want it to be based on the most recent year's ending savings balance. So this part, K34 column, row 34 is fine here, but we need to come in here and lock in the cell reference. Now remember, before we manually kind of hit the $sign to lock in the reference to column C. Another way of doing that is using, again, keyboard shortcut. If you're selected, if I'm right before C or even here, like right before the 3, if I just hit F4, I can actually hit it multiple times and it's going to cycle through the different combinations, locking through the column, locking in the row, or locking in both like it is right here. So that's a quick way to lock in a reference, is to highlight that, click F4. So we've done that. Now when I drag over to the right, still referencing the 4%. Now it's still 0 because we haven't populated our ending savings balance, but we will do that soon enough and we should see these numbers update. Now they're not formatted as dollars, and they probably should be. We would want that return on savings to be in dollars. Again, we could right click on it, go into format cells, go into currency, choose this format, and do that for each one without the decimals, or use that convenient format painter option to copy the formatting to all of those cells. I'm going to highlight this row, which has the exact format we want it to be in, $sign in front, no decimals. Click the format painter, and it's very important that you click in the first cell where you want the copying to start, which would be for us C17 here. And there you go, we've got it updated. Now maybe we go ahead and do that for our next row, total income, which we'd also want to be in dollars with no decimal sign. Let's do that. We also would want, let's center this. So we'll do center. Some people might prefer left align, some centering. We'll center for now. Now we're wanting to do a sum of salary and return on savings to get our total income. And a very simple way to do that would be to say equals this cell, 50,000, plus the 2,000, the return on savings, and that gets us our total. So we're simply typing in a formula, and you can see we used a plus sign. Makes sense. We could use minus. We saw that you could use the star sign if you wanted to multiply, but we want to add here. That's certainly a valid way to do that. Let's see, like this. Another way though, and this will really pay off when we do our total expense calculation, is to use a function. Now functions are big in any analytics platform. They do things, and like in the one we're going to use, sum, they allow us to aggregate across multiple things, but functions do all kinds of things. In this case, instead of doing that sum operation, we'll still start off with an equal sign, but we're going to refer to a function name, and that function is going to be called sum. And a function in a lot of platforms, but in Excel in particular, starts with the function name, open parentheses, and then as you can see here, it'll take a set of arguments. For sum, the arguments are simply the cells that you want to add up. So in one case, we have the salary, 50,000. We want to use a comma, and we want to enter all the other things that we want to sum. In this case, the 2,000 as well. We can do that. We can close parentheses that ends the function, and press enter. And now that's another way of calculating a sum. Instead of using the plus sign, we used a function name called sum that adds the cells that are separated by commas. Now again, in the expense case, this is really going to come in handy. Rather than individually selecting all of those, in Excel what we can do is actually highlight the cells in a range. So in this case it'd just be 2, but you could do however many cells that you needed to add. You can just highlight them all. And notice what happens here in our formula. You end up with a colon that shows from this cell to this cell, we want to select all of those. So same sum function we were using before when we used commas, but now we're using colons, a colon to select a range of cells. So that's a especially efficient way to calculate a sum. We do that. See what happens when we go to the bottom right of the cell, drag over. Looks good. I'm going to double click here. Yep, it scrolls over and adds the salary and the return on savings for that row. Now in accounting and even in math itself, we often use an underline to denote a sum. And so let's do that in this case and make it very clear that salary and return on savings are being added to get to our total sum. And I could just go to a particular cell and highlight this border option. You can do a thick border or a thin border, but if you wanted to do it across all the cells, we can highlight all of these cells, go back to our border option, bottom border, and look at that. It's very clear that salary and return on savings are being added to get to total income. Hey, our income section is looking really good. It's time to go down to our expenses section, and we're going to start that with a calculated column of taxes. Now taxes would simply be equal to salary. We want it to be dynamic, so we're going to reference the salary row here, and then multiply that by our parameter, which is tax rate. And we're not going to make the same mistake we did before of not locking in our cell for the tax rate, so I'm going to use the keyboard shortcut F4 to lock it in, and there's our taxes for 2023. We'll take this formula, go to the bottom right, we want to drag it over. We'll just see some examples here. Okay, this is taking our new salary for 2024, multiplying by the same 20% tax rate. Now, in practice, as your income goes up, usually your tax rate would go up as well, depending on the country you're in. But we would scroll that over, and you can see what's really neat about this is now we're able to forecast what our taxes will be based on a forecasted salary based on an assumed salary growth. We have a lot of things that are linked together here, which is pretty neat. It's pretty neat functionality that Excel has in that way. All right, so we've calculated our taxes. Now, giving, that was going to be the salary times our giving percentage as well, 10%. Let's multiply that out and lock in the giving rate for the parameter that we've set in cell C7. There we go. Drag that across as well. All right. Now both of these are annual figures because they're referencing an annual salary. Our mortgage or our rent, usually the way we think about that is from a monthly basis. Now we could go ahead and put a particular mortgage value here. So I'm thinking, let's use a value of $1,200 per month. But our values here are actually annual values, so we would need to adjust that. And you could potentially use a calculator or hard code in what 1200 times 12 is and put that value here. I find that if a lot of people are going to think about something like a mortgage from a monthly basis, doing the calculation at an annual level, it's probably more intuitive if someone were to click into the cell to say equals the more intuitive value, a monthly rate of 1200 times 12. That'll be way more intuitive than just taking the result of that and just hard coding in whatever that equals. Putting equals 14,400 in here. Folks might think, how'd you get that? Hopefully it's clear that that's the mortgage for 2023, but I think even more intuitive would be to have the formula here that they can click into and say, oh yeah, 1,200 mortgage a month times 12 months makes sense. Now, what we'll assume here is that the inflation doesn't impact this. We'll make that assumption that the mortgage is kind of locked in for the next 10 years. And that makes the rest of the formula really easy. It's just going to always equal this cell. And if we drag that over, it's always going to equal the preceding cell. We're not adding anything to it, so it stays constant across all of the years. That's our assumption. Now we've kind of hard-coded, at least for this first cell, our mortgage rate. Maybe it makes sense to actually bake in some parameters at the top for some of these expenses, like what our mortgage is. That way we don't have to hunt down that row and update it here. It'll just be easier to have all of our inputted parameters at the top. So I might go ahead and do that. I'm going to say mortgage, and then we'll just take this exact formula, I'm going to copy it, paste it in here, using Control-C to copy this, Control-V to paste it. I'm going to copy the formatting over, so click on this dollar formatting with no decimals, take that format painter, apply it there. Okay, that's looking better. And then I will left align that. Now we're probably going to need to do the same thing with car payment, utilities, with groceries, with other. I'm just going to go ahead and make all of those parameters at the top so we can focus on making updates at the top, and then everything down here is going to be calculated. I think that'll be a nice way to set it up. So I'm copying over those categories. Let's see, car payment, similar to mortgage. A lot of people think about that from a monthly basis as well. So we're going to set that to be a monthly value. In fact, let's go ahead and set our make this a monthly mortgage. So we use the 1,200 here, and then we'll actually apply the annualizing of it in the spreadsheet below, the cells below. So we'll taking that monthly mortgage, multiplying by 12. Now car payment, this is an interesting one. Car payment, I don't know if you can expect a car to be reliable for 10 years. Maybe in some cases you can, but there could be some inflation, and so at a certain point, really your cash flow model might look more like at a certain point you expect to buy a new car, and then that has an impact on your car payment. Let's say that they're taking into account trade-in values and inflation and all of that. Let's just apply our inflation rate to the car payment, just to create a little bit of a simpler model. And so in that sense, this won't just be a consistent car payment, it'll be our starting car payment, and we'll assume that utilities are impacted by the inflation rate as well. So we'll call this starting utilities. Same thing with groceries, starting groceries. So this is all of these are a value that we expect for 2023, and starting other category for expenses that don't fit into the ones we've been specific about. All right, so we'll say $300 for our starting car payment. Let's just say starting utilities, $300. We'll say our starting groceries are $300, and we'll say our other bucket is $300 as well for starters. I'm going to left align all of these and want to be consistent. I'm going to call out anything that's a inputted parameter, and I'm going to highlight it in yellow here. All right, back down here, we're going to point to our starting car payment here, starting utilities here, starting groceries. By the way, since all of these things are in the same order, I could just drag this down. Now, again, I forgot, something looks off here, applied some sanity checks and realized, okay, car payment, $300 for 2023, probably need to multiply that by 12 since that's our monthly value. And same thing for all of these values. So this gets the starting other, which is a monthly value, multiplies it by 12. And I should probably specify, it's good to be very clear about what something represents. I'm going to specify that these are all monthly values. Now notice, now we need to widen this column, and the easy way to do that, double click on the right side of that column. There you go, it stretches it out for us again. Looking good for 2023. Now remember, our car payment and utilities and groceries and other, it's not going to be as simple as mortgage where it's consistent for the next 10 years. We are going to assume some inflation, so it's going to be really similar to what we did with our salary, where he said take the prior year and add a certain percentage, 1 plus a certain percentage. In this case, it's a percentage that represents how much we think our expenses are going to increase year over year. So it wouldn't be a bad idea to maybe do Control-C to copy this, or right-click on it and say copy, paste it here. Let's just double-click and see what the formula is referring to. Okay, it's referring to the prior cell, and this thing is moved, which is kind of expected, but we want to go ahead and take that and apply it to the inflation rate. So we're going to do the previous car payment, 1 plus the inflation rate. You know, I'm going to do a $ in front of everything in this case, so that when we drag it down, it keeps it on the inflation rate as well. And when we drag it to the right, it also stays on the same 4% inflation. Drag that to the right. Okay, just double click, make sure, yep, 2032 is taking 2031's car payment and adding 4% to it. Looks good. Let's just drag this down for all of our expenses and see how that looks. Okay, other category for 2023, still 1 plus 4% because we locked the letter and the number, the column and the row, using the $. That's looking really good. I'm going to highlight all 3 of these, drag them all over. So you can highlight multiple rows and drag them over at the same time. Really neat functionality here. And as you can see, since our starting monthly car payment, utilities, groceries, other, everything's $300, everything is consistent here. And we have, it looks like, updated all of our expenses, which is great. Now we're ready to do something very similar to what we did for income. In fact, maybe I'll just go ahead and copy this sum formula down here. But notice that it's only going to capture the 2 cells above. We can actually just go in here and easily stretch it out so that now it's going from cell C26 to C32, adding all of those up. And I'll just go ahead and take that new formula that captures all of the rows, drag that over to the right. Great, looking good. Now we had this bar to denote the fact that we were summing up all of these line items to get to our total income. We'll do the same thing for our total expenses. I'm going to highlight these two rows since the underscore is kind of between them in this case. It doesn't hurt anything. I'm going to do Format Painter, and I'm going to paste it in the same area that I want that line to be applied. Looking good. And I'll also center these to be consistent with the income section. So everything is centered. All right, looking great so far. We've got one more section down here, our savings section. Savings is very simple calculation. It is your income for that year minus your total expenses for that year. This would suggest that we're going to save $8,200 in the first year, and we can drag that over, wow, and see a forecast of how much we're going to save each year. Well, that's nice to see. And a next question we might have is, well, if we're going to save that much each year, what would our final savings be? And what would the savings be at each point, after each year? So our starting savings balance, or ending savings balance for 2023, this one will be unique because it's the first year we're looking at. We're going to come up here and point to our starting savings balance so that if that needs to be updated, we can, and it'll flow through. But we're going to take that starting savings balance for 2023 and we'll add the amount of savings we got in 2023, 8,200, but we'll reference it dynamically. We're not going to hard code 8,200. And there we have our ending savings balance for 2023. Now, if we were to drag this over, it'll still be referencing the cells up here. So we're going to, for 2024 and beyond, perform a different calculation to calculate our savings balance. Our savings balance will simply be what was your ending savings balance for the previous year, add to that whatever your savings is for that year, and that will be your new ending savings balance for 2024. And at this point we can simply drag it over. This is, I guess it's a good thing, we've got some large numbers here, and in order to adjust for that we can maybe double click here, and yep, everything's kind of been adjusted. Now these cells are a little bit larger than these cells. I want to kind of keep it consistent, so I'm going to highlight all of the columns and then just make a slight adjustment there so that everything, all the years end up having the same width. We have a little more width for the first column, which I think is fine. I'm going to center these. It's looking good. Well, something I might do here is highlight this section in bold, or put the totals in bold. So I'm going to highlight that entire row, click on bold. Same thing here, bold, bold. Now there is a calculation, I guess there's a calculation happening with both of these, so I don't know. Yeah, savings balance is kind of what we're really trying to monitor, so I'll go ahead and put that there, and I might even put an underline here since there's some calculations being happening there. All right, so we are actually able to use this forecasting model, and based on our assumptions at least, we can kind of estimate what our savings balance would be after any year in the next 10 years. And of course, we could go further out than that. So I'll zoom out a little bit so we can maybe get a final snapshot of what our model looks like. Might even consider moving some of this over here so we don't have as much space, but yeah, we've got our starting savings balance that can be updated, rate of return, salary, growth rate, tax rate, giving percentage, and inflation rate, our expense assumptions, and all of that flows through this model. Nothing is hard-coded down here, which is really neat. It means you can make all of your updates to assumptions up here. And so if we say, well, what if my starting salary was $60,000? What does that do? Imagine trying to calculate this by hand, starting with a salary of $50,000, and then for some reason you make an adjustment and you've calculated all of it and you forecast it out to 2032, and you say, Yep, I should have, I'm expecting to have savings of going from 50,000 currently to 173,000 in 10 years. And then you say, oh, I messed something. I should have used a different inflation rate or a different starting salary, or you just wanted to see what it would be with a different salary. This allows you to simply update that cell. And now you can see, wow, if I go from 50,000 to 60,000 as my current starting salary, my savings goes up from 170 or 80,000 like it was before to about 270,000 instead 10 years from now. So cool that you just simply update one cell and everything else updates. So I hope you've gotten a lot out of this. I hope you can use this in your personal life. And if you really want to make this a little more actionable, if you think about it, this will be your homework assignment. I'll give you a preview into it now. If you think about it, people probably want to monitor how they're doing against their budget, what they've planned out on a more frequent basis than annually. Monthly might be a more regular cadence. So what I'd like for you to do is consider this as your annual budget. Let's right click and rename it annual budget. Now I'd like for you to create your own monthly budget. So you might create another tab here, rename it monthly budget. Again, if you want to turn off grid lines like I do, you can just go to view and turn off grid lines. But think about taking this, perhaps linking to this, so it uses the same assumptions, but perhaps you take the annual number here, divide it by 12, or you could get more specific about how you want to divide it by month, but create something that maybe has a column for every month. And also think about not just planning, but can you create a way where you can enter what your actuals were, line by line, so that you can monitor and see, okay, here's what I expected for my other category, here's what it actually was, here's the difference. And ultimately, if you're not, maybe you're exceeding what you planned from a savings perspective, maybe you haven't saved as much as you planned. You can look line item by line item to see what's contributing to that difference from plan the most, and really allow you to adjust from there. And that's our personal finance use case. I hope you enjoyed it. I want to thank you all for coming out to this post-analysis interview today. You know, this was a tough one. We ran into a few coding issues early on. Hey, I got to give them a lot of credit. I'll be honest, there were a few times I didn't know what we were going to do, but we hung in there, like value-driven analytics always does. We did a great job troubleshooting, and we got everything emailed out by 5.
Were you worn out after such an exhaustive analysis?
Listen, Coach always tells us it's an 8-hour day, unless we go into overtime. And today, we needed all 8 hours. But we came in and we got the W, and I'll tell you what, we're going to enjoy this one tonight. Probably go out to ice cream, maybe even get a double scoop.
What does this win today mean to you?
Well, it's not every day that we get the opportunity to take data and turn it into something meaningful, a new decision. All right, who's ready for some football? I hope you are, because in our second demo here, we're going to look at a data set that is one row per college football game, going pretty far back. And we're going to use that to understand whether a team's regular season winning percentage can be used to predict the likelihood that they'll win their postseason game. Very neat opportunity to do some sports analysis, and again, I hope it spurs some more ideas for different ways you could analyze college football games or other sports games as well. So let's get into Excel and do some college football analysis. All right, before we can get into Excel, we need to download the college football data set. And to do that, head over to valuedrivenanalytics.com, go to the analytics training session, and then click on Session 2, Introduction to Excel. I'll go ahead and do that here. Now we're on the session page. I want you to scroll down, and there you'll find several different files from today's session. First, the presentation slides that we went through. We've got those right here. we also have the final personal finance workbook that we just created with our budget. So if you'd like to see the final version of that, you can download that there. Now, the data set that we're going to be looking at today was actually downloaded from a Python API. I wrote some Python code in a Jupyter notebook and was able to grab all of that data. Just one example of many Python APIs that you can use to get publicly available data. So if you'd like to see that Python code, you can download it right here. Now you don't need to. I understand at this point you may not have done any Python coding, but if you have and you want to check that out, you can download that. Or perhaps after you've gone through the Python session that we'll cover eventually, you might come back to here and check out this code. It's very brief, very easy to download so much college football game history. So what I've done for you in this case, since you may not have that Python experience, is I've ran that for you, and you can download the results, this collegefootballgames.xlsx Excel file right here. So go ahead and click on this. It'll start a download for our college football Excel file, and then go ahead and open that up and you'll be ready to analyze the college football games. Now, while we're here, I'll also point out that we'll have our final college football games analysis available right here. So if you want to see the final result we're about to work on, come back and visit that. And our final financial modeling workbook that we'll plan on doing as our third use case today. All those files available on the Introduction to Excel webpage on valuedrivenanalytics.com. And now we're ready to start our college football analysis. Well, I hope you've got your helmet on, your shoulder pads on, because we are about to perform some college football analysis in Excel. Now, we've got our data set open. We've downloaded it from the website. Again, this is one row per college football game from the 1998 season listed first here. And if we scroll all the way down, we can see the latest college football game from the 2022 season that was actually played in 2023. The big one, Georgia versus TCU. Some of you might remember that game. And that's our college football data set. Now remember, one of the neat things we can do just to get a high-level overview of what our data represents is to highlight any column, especially one that doesn't have any null values, because again, null values don't get counted in the summary statistics. So I'm going to highlight the season type, and we can see a count of 35,000 games roughly. 35,000. Believe this is NCAA Division I games that have been played between the 1998 and the 2022 season. Very cool. All right, well, let's start analyzing it. One of the things I'd like to do is I'm going to expand all of these columns, and in order to do that efficiently, just highlight all of them, double click on the first column's right edge, column A's edge, and there we go. We've got it expanded so we can kind of see things better here. The date I think was getting cut off before. I'm going to do a left align for all of these, kind of like that format. Again, sometimes I like to turn off the grid lines. In this case, I'm going to leave them on. And there we go. We've got our data set. It's called games here. I'm kind of going to preserve this as our comprehensive starting data set. But our task today is to try to use the regular season winning percentage difference between two teams that are playing each other in the postseason, and see if we can use that difference in their regular season winning percentage to predict which team actually wins the postseason game. And so in order to do that, we are going to need to get just the postseason games by themselves, at least initially, and then we'll look at the regular season games as well. So in order to do that, I will highlight the entire table. Now, before we've highlighted columns, we've highlighted rows, maybe because we wanted to insert a row or something like that. In this case, we want to copy the entire table. And to do that efficiently, we could just kind of try to do that manually. There's a lot of rows here, but a quicker way to do that, click on this top left corner, highlights the entire worksheet. Very handy. And from there, we can right click and anywhere in the body here and say copy. and then I'm going to click the plus sign to create a new worksheet here. I'm going to go to the very top left corner again, same place I clicked to copy before. I'm going to select the whole worksheet, right click on the body, and say paste. I'm just going to do a regular paste here. There we go. We've got a copy of the worksheet. Now another thing we could have done, in fact I'll maybe do this in this case. I'll delete this. Yep. And I will right click on this and say move or copy. And I will say create a copy. And there you go. I've got a games 2. Now I'm going to call this my postseason games. So we're eventually going to filter this down to just postseason games. Postseason games. Right now, our original data set has both regular season games and also has postseason games. Now, a quick way to see this, I guess one method, if we go to the very bottom, we can definitely see that there's postseason games included in this worksheet. But for our postseason games, we want to just have postseason season type. So I'm going to highlight the whole thing again, and I am going to go to the Data tab to apply some filters, and it will apply filters to our header row right here that has each of the column names. Great. Now we can filter on season type, and it'll show us any values that show up in this column. In this case, there's only 2 unique values, postseason or regular season, and we would like to see the postseason rows. We're essentially doing a filter here. This is one way of doing filtering in Excel. In SQL, you might use a where statement. You can use all kinds of things in Python, or there's different ways of filtering in Power BI and Excel. It's very common to use this filtering functionality to filter down your rows. There we go. Now we have just postseason games, and watch this. I'm going to highlight this column again, and instead of seeing about 35,000 or so games since 1998, we have about 900 or so postseason games since 1998. Very interesting. So we know that we filtered down based on that. Now, don't let this filtering fool you. We've filtered it down from a visualization perspective. There are still other rows behind the scenes of this data set, and so one thing we can potentially do to get rid of all of that and to make sure this is truly just postseason games is what we might want to do. Right click, copy, and I'll just maybe paste this in its own area here. Now I've copied and pasted special values. I'll do that again. Paste special and then choose values. Okay. And now I have the filter isn't even shown there anymore because I pasted it in a new workbook here. But you can see it's just postseason games. I'll just check the count here again. Okay, highlighting that column 892. All right, so actually I'm going to do rename just so I can copy the postseason games here. But I'm going to delete this version that has technically all the games but just a filter applied for postseason. Delete that now, and I'm going to call this our postseason games. There we go. So we filtered it down and then we applied it. Now I guess a quicker way to do that would just be to apply the filter in our original games table and then copy and paste it. Different ways of getting there. We'll come back to that as well. Okay, so we've got our table. This is a new worksheet. I'm going to go ahead and highlight all of these, double click on the right edge of A so that we can see all of the table. I'm going to go back to the Home tab here, left align everything. Great, we have our postseason games. Now the first thing I'm going to do is create an indicator for whether the home team won that particular postseason game. And in order to do that, I'm going to add a new column header here. I'll call it won. Maybe be more specific about it. Home team won. And I'm going to write a formula in this cell J2 right below the home team won. And so in order to do that, I'm going to start off with an equal sign, and I'm going to use another function. We learned about the sum function before in our personal finance use case. This time I'm going to use the if function. Say if the home points are greater than the away points, that is a 1, otherwise a 0. So a function, again, takes in multiple arguments, and for the if statement, you can even see this before we close it off with the closed parentheses, a logical test. The test is whether the home points are greater than the away points, whether this cell is greater than this cell. And then comma, the next argument is what do you want the value of this cell that we're calculating right now, column J, what do you want it to equal if that condition is true, if the home points are greater than the away points, and what do you want it to equal if it's false? Well, you want it to be a 1 if it's true, a 0 if false. Close that off, it's a 1, great. Now we could drag this down for all of our other formulas. In this case, we don't want to lock the cells. Look at that, it just populated everything and it scooted the cells down for each row, which is great. That's what we want in this case. Another way of getting there quicker is actually to take this formula that we've written, go to the bottom right, and you'll see the icon changes a little bit, the cursor changes. Double click on that. It'll go down here by default, and then we'll just do double click, and it should take it all the way down. Yes. Great. Well, there were a lot of home team wins in this particular season. You can see here's a case where the away team had more points than the home team, but eventually you see, a good variety of home teams winning their postseason games and away teams winning their game. So we've got an indicator here. Now I'll go ahead and left align that one too. Double click that so that we have it expanded, see the whole title in column J. Why didn't we just create an indicator variable? Why didn't we do something like, okay, if the home team points are higher than the away team points, let's say that they won, and then if not, we'll say that they lost. Why didn't we code it that way? When it comes to building models and even doing analysis, it's really helpful to have what are called binary indicator variables. What makes this really nice is that by having it a 1 if they won, or a 0 if they lost, or in other cases, maybe it's a 1 if a customer bought, or a 0 if they didn't. When you have a binary indicator variable like that, you can take a simple average of it. So I'll do Control Z to go back to our old formula. You can take a simple average of that variable, that 1 or 0 variable, and that simple average tells you the percentage of all of your observations where that is true, a 1, or where it's 0. So in this case, I'm going to highlight column J, and one of the summary statistics it gives me at the bottom is the average. This average, 0.58, tells me right away that 58% of the games over this time period, 58% of those postseason games, the home team won. I can see that right away. Now, I guess I might start by thinking that maybe it's a 50-50 chance that a home team wins, but generally the better team often gets the home team field advantage, and then sometimes there's an advantage to being the home team. Maybe they have more fans there that are rooting for them. All kinds of things that could lead to that being a little bit higher. So that 58% seems somewhat reasonable to me. I'm trying to apply some sanity checks along the way. And this is a great start. Now, our objective is to look at that home team winning percentage and understand whether the regular season winning percentage had an impact on it. So we need to bring in both the home team's winning percentage for that season and the away team's winning percentage for that season to proceed with our analysis. Now this data set is only postseason games, so we're going to need to go back to our original games data set that has all the games, regular season and postseason. And I'm going to go ahead and highlight the whole thing by clicking on the top left here. I will go to the data tab, filter. I'm going to filter on season type, go to regular season. There we go. Now I'm going to click on the top left corner again. right click in the body, copy, click the plus sign to create a new worksheet. Click in the top left to select the whole worksheet, the new one. Right click, paste special, the values, okay. There we go. We've got all our regular season games. Let's count them up. Okay, about 34,500 or so. Very good. Now we've got our regular season winning percentages. So let's take a look at this. Expand all our columns. Left align. Great. Now here's an interesting thing about the regular season games. When we calculate all of the performance for a team, we could potentially group by the home team, and we might start there and think, yeah, if we just simply calculate the winning percentage among this home team field, then we'll be able to calculate their home team's winnings percentage. Very easy, right? But what we would miss there is any of the games that that team, Nebraska for instance, if we group by this column, we would miss all of Nebraska's away team games. We wouldn't factor them in. So we need to look at these games from a home team perspective, but also an away team perspective. And so we'll create two different worksheets and then union them all together. All right, before we do that, let's do a let's just kind of assess this from a home team perspective. So I'm going to say game type here. I will call this home. Game type is going to be home for everything in this worksheet. The team column is going to represent the home team because this is games from a home team perspective. So I'll just click on that, and then to bring down that formula, just click on the bottom right, double click. There we go. And then we're going to create an indicator for whether the home team won, similar to what we did with the postseason games already. So I'll say win or won. And it'll be the if statement equals if first argument is condition. Were the home points greater than the away points, comma, if that condition is true, we want it to be a 1. If that condition is not true, we want it to be a 0. Close our function. There we go. Drag that down by clicking the bottom right corner, double clicking that, drag it all the way down. Perfect. And let's also calculate not just whether they won, but maybe it'll be useful to have the point differential as well from the home team's perspective. Positive if they won, negative if they didn't. We'll call that point differential. And that'll simply be equal to home points minus away points. Okay, click the bottom right corner, double click it, scrolls all the way down. Great. I'm just gonna take a look at a few of these. Yep, 16 is less than 23. They lost by 7 points. These columns are looking great. So this is going to be our regular season. I'm just going to maybe do RS for regular season home games. Now we need to do this for away games. I'm going to right click on RS home games, move or copy, create a copy, okay. Now we have the exact table duplicated, and it just puts a 2 after it. I'm going to rename this and call it away games. All right, we've got away games now. Great. And what we need to do from here is update the game type to be away in this case. Just drag that, just double click the bottom right corner, getting used to that. Now the team in this case is not the home team. The team is going to be the away team for our away games. That makes sense. So we need to point it to column G in this case. What do things look like from an away team perspective? There we go. We also need to update our won column to reflect whether the away team won that game. So we're essentially, what we can kind of do here is switch these around and say, okay, now in this case we want to know whether the away points I2 for this row are greater than H2, the home points, and if so, that's a 1. That's a win from the away team's perspective. Otherwise, it's a 0, a non-win. There we go, and we need to drag that down. Be sure to drag that down. Double click on that. Good. Same thing with point differential. Now instead of doing the home points minus away points, we're going to calculate it from an away team perspective, and I could either start over or I'll just switch these around and say, all right, we're going to start with the away points, subtract the home points, and that'll be the away team's point differential. Be sure to drag that down as well. All right, let's make sure we did this right. Did the away team win? Yes, they did. Colorado 23, Michigan State 16 back in 1998, and they won. Colorado won by 7 points, so it's a positive 7 for Colorado. Let's just compare that to our home games here. Yeah, from the home team's perspective, Michigan State, notice it was a 0, and it was a loss of 7 points. That's great. This is exactly what we want. I forgot to include the RS before. Yeah, good. Now what we need to do before the next step is we need to combine these games. We've got games from the away team's perspective in this worksheet. We've got games from the home team's perspective in the home games worksheet. We need to combine these. I'll just keep these tabs for reference. I'm going to start with just a brand new blank slate and just call this RS games. It'll be the combination of home and away games. So in order to do this, I could have just copied this tab to start with, but I'm going to click in the top left corner, highlight all of the home games, right click, copy, head to our new RS games, total games worksheet, click in the top left corner, right click, paste special, values. There we go. We've got all of our home games over here. Now we need to add the away games. So in order to do that, I'm going to scroll all the way to the bottom. I finally got to the end of that table. Now it's important when you do what we're about to do, which is called a union in SQL. It's called sometimes a concatenation in other languages like pandas and Python. When we do a union or concatenation, we need to make sure the columns are in exactly the same order. Everything is set up very similarly, and that is exactly the case for this. We made sure we didn't add any columns or anything when we created this away worksheet. All we did was update these last 4 columns. So what that allows me to do, we don't want to copy over the headers. We don't need the headers. We already have the headers when we brought over the home games. But we want to start with the second row, the first row of real data in the away game spreadsheet. I'll highlight that. And what we could do is just kind of scroll down like this. You can see this is going to take some time. If I keep going like this, there's a more efficient way to do it. So after you've even just highlighted a few rows, I've highlighted all the columns that I need. From there, to select the rest of the rows in the worksheet, what you can do is use a keyboard shortcut. I'm going to do Control, Shift, End to hit all of those in that order all at the same time, and then let go of the key. And look at that. It's automatically selected everything all the way to the bottom, all 34,500 or so records. And now I can right click, say copy. I'll come over to RS Games. I went to the very bottom of the worksheet, and now I can say right click in the first kind of top left where I want this new data I've just copied to go. I'll just say paste special values. When I paste special values, I remove any formulas that I did before. So if you want those formulas to stay, be careful, because sometimes they can get corrupted when you do certain types of copy operations. Most of the time they're probably okay. But if you want to remove any of those formulas, essentially you're going from formulas to hard coding, which is sometimes not good. I know we don't like to hard code in a lot of cases, but in other cases it can prevent linking issues when you copy data to like a brand new worksheet. Just keep an eye on how your formulas change when you do copy and paste formulas to make sure everything's fine. In this case, we're going to copy paste special values. And there we go. We've got the home games and the away games all together in one perspective. This is in one table. That's great. Now these fields, especially home team, away team, conference, I don't think we're going to need these anymore from this total games perspective. So I'm going to delete those by highlighting the cells, right clicking, saying delete. Now start date, somewhere along the line, start date turned to a number. Sometimes Excel formats a date as a number of days since a particular day, and you can change that by highlighting the entire cell. You could do it cell by cell, but a more efficient way would be to highlight the column, right click, format cells, and tell it that this is a date. It should be formatted as a date, and you can tell it the way you want that date to show up, the format, whether you want it to use dashes or slashes or whatnot, and we'll say OK. There you go. We have the start date formatted as an actual date. Great. Well, this is looking like a good comprehensive game table. Now the next thing we need to do, this is a very granular table. It has now it has about 70,000 rows because it has games from both the home team's perspective and the away team's perspective. We need to now group by the team field, and now that we've done that in this comprehensive away and home team game data set, when we group by team, we'll have all of that team's history for that season represented. But before we even aggregate, we're going to need to create another field here that is the team season combination. Initially, I would think, well, I need to group by team and then bring that into our postseason games. But a team in one year can be quite different from the team in the next year. So really what we want to do is bring in that team's history for that particular year. So we're going to create a field in Excel. Oftentimes you have to kind of create a field that is the combination of all the fields that you want to join on. And in this case, we want to join on not just team, but also the season as well. So we'll call this team season, and it'll be based on a formula. This is an interesting formula. Now in this case, we're going to deal not with quantitative fields, but with qualitative fields, character fields. It's important to understand the data type you're dealing with. So in this case, we're going to deal with some character or qualitative fields. We're still going to use the equal sign. We're going to point to the team. This field will represent the team, and then we want that to maybe we'll use a hyphen to separate that from the season. So I'm going to concatenate by using the and sign, and that just tells Excel that we're about to give you another character. We want you to combine it with the previous character, the team, and combine, and then we'll put this in quotes. So double quotes, dash, double quotes, and then we're going to concatenate to that the season. And I'll press enter. That looks good. Okay, we've got the team, dash, and then the regular the season, all put together. Go to the bottom right here, double click to scroll that all the way down. Looking good. So now we have our team season, and at this point I think we're ready to go ahead and do some aggregation. Now there's probably a few ways of doing aggregation in Excel, but a very common way, you will do well to learn this feature. It is very popular, but yet some people that use Excel do not know about it. So you're about to learn about it, which is great. What I'd like for you to do is click on the top left of our RS Games worksheet and select all the data. Essentially, we want you to select the data what we're about to do is going to be based on, and we're going to go to the Insert tab, say Pivot Table. All right, you can say this is the range of data. It's all rows essentially from columns A through H. Where do you want it? We'll put our pivot table in a new worksheet. That's fine. Just click OK. All right, and we have a pivot table here. Perfect. It just gives it a default name of sheet 7. We'll call this winning percentage. by team. It's really by team and season, I guess, by team season. All right, great. Well, we've got this table over here, we've got fields here, and we have some different places that we can drag those fields to. In this case, we are going to be using the rows feature, and we want our table to be one row per team season combination, and that's why we created that field team season. So I'm going to just go ahead and drag that to rows. Great, look at that. All right, so we've got each team, we've got their team dash season represented here. Perfect. All right, now we're going to want to bring in our won variable. So here it is right here. That is going to go in the values place. So this is a quantitative field, a 1 or a 0. Let's see what happens by default when we drop it here. It wants to sum it up. It wants to tell us here's how many times that team had a win in that particular season. Well, each team usually plays about the same number of games, but they could have played a different number of games in the regular season. And so we don't want to look at it from a sum perspective. We want to look at it from an average perspective. And remember, because this is a binary indicator variable, it's a 1 if they won, a 0 if not, taking the average is a way that we can just calculate what percentage of the time did they win. I suppose another way of calculating that would be to do the sum of how many times they won divided by the total number of games. But doing the average of a binary 1-0 variable is a much quicker way of doing that. So that's what we'll do here. If we want to change the function being applied to that quantitative variable, we can just simply click on value field settings and say average. There we go. All right, we've got as a decimal here. I'll go ahead and click on the whole column, right click, format, so we can change the format for everything. We want this to be as a percentage. I'll do 2 decimals is fine for now. There we go. All right. So we see each team's winning percentage in that particular year. Really interesting. Now we can highlight this and we can well, it looks like we only have a few summary statistics by default here. I'm going to right click here, and I believe we have the ability to add some other things like minimum, like maximum. So there was some teams, unfortunately, they lost all their games that season, and there were other teams that, yeah, sometimes win all their games. You have a pretty good variety there. Well, that's our winning percentage. Now, eventually, I think we're ready to come back, and what we want to do is bring this winning percentage into our postseason games. We want to add that as an attribute to this table. Okay, we just did some aggregation when we used that pivot table, and that is an extremely common and important technique. We talked about it in the Introduction to Analytics session of the series. Now we're about to do another really important type of manipulation, and that is take data from one data table and bring it into another data table. Sometimes we call that merging or joining. Whatever you want to call it, we're about to do that now. We need to do it because we need to get the winning percentage, the regular season winning percentage for the home team, for the away team, into this postseason games table so we can use that as an attribute to analyze. Now, in order to, whether you're dealing with SQL or Python or Excel, you've got to tell the system what to join the two tables on. And remember, in our case, we don't want to just join on team, but we want to look at, for that team in that season, what was their regular season winning percentage. And we need to code it in the same formatting that we used when we created our pivot table, the source that we're about to join to. So to start off with, we need to create the home team season variable, and we've got to code it exactly the same way we did before in order for it to be consistent. If we decided to put the season first and then a dash or another character and then the team, there would not be a match. They would be formatted differently. So we need to be sure that we say, okay, start with the team exactly like we did before, and sign, double quote, dash, double quote, and sign, concatenating to the season. That is the format we used before. We need to make sure we keep that consistent. So I'm going to just code that out, write the formula. I'm going to double click the bottom right corner here to drag it down. I'm going to double click the right edge of column K to expand it. And there we go. We've got the thing that we need to match on. Again, look at our winning percentage by team season. That's the format that it's in. It's team dash season. All right, this is where the joining is. Watch this. This is exciting. The variable that we're about to bring in, we need to give it an intuitive name. Let's call it home team winning percentage, and it's our regular season. I'll abbreviate RS for regular season. Home team RS winning percentage. I think that's probably a good name for it. We've already calculated that. It's in our pivot table tab, our winning percentage by team season worksheet. We just need to bring it into the workbook. Now there's a few ways of doing that to bring it into this tab. You can use a VLOOKUP. In certain cases, if you're looking it up from a horizontal perspective, you could look at using HLOOKUP. In our case, and this works for vertical or horizontal lookups, we're going to use a relatively new feature in Excel called the XLOOKUP function. It starts with an equal sign, like all functions do. XLOOKUP. And what you'll see here is a little bit of guidance around what each function should represent. So the first one is our lookup value. And it's the lookup value for this particular worksheet, and that would simply be K2 for this particular row. We want you to look up Marshall 1998. Great. Next question, next argument, and all arguments are always separated by commas. Where do you want us to look that up? Okay, I want you to look it up over on this tab, and I'm going to highlight column A. Column A is where I want you to look up that value. Great. Comma. Next argument is, what do you want us to return if we find that? Well, I want you to return column B, essentially. So I'm going to see if I can get, well, I'm just going to copy this. I would like to just select, it looks like I can. It's right behind this guidance here. All right, I'm going to double click back in here. Okay, where do we want to return? What do we want to return? It is this same worksheet, but in this case, we would want it to return column B. And then from there, there are a few optional things, I believe. This, if not found, usually you want to set that to false, which kind of tells it, I think, not to guess or look at the closest match. I almost pretty much always use false there. And then I'm not worried about the other. There are some advanced features that you could use as well if you need a more advanced kind of join. But in this case, this should work just fine. I'm going to use the close parentheses. Look at that. Look at that. Home team is Marshall, and it's 1998, and it returns 0.90, which would be about a 91% winning percentage for Marshall in 1998. Now let's test this. Make sure it worked. I'm going to grab this value, Marshall 1998, and go back to the winning percentage by team season where we looked it up. Again, we return column B, which has our winning percentage for that team season combination. I'll do Control F. This is a neat feature where you can look for a particular value. And then we'll type that in here, Marshall 1998. I'll say find next. It found it. And look at that. The winning percentage is about 91%. So our XLOOKUP function absolutely worked. Great to see that. Go back to our post-season games, and I'm going to drag that formula all the way down. Look at that. Great. Looks good. Now let's do the same thing, but from the away team's perspective. Since we're going to do roughly the same thing, it's a great copy-paste use case. I'll simply start by highlighting the two home team season, home team regular season winning percentage columns, highlighting the first two rows. The first row for the headers and the second row, because it's the first row that has a formula in it. Could do Control C, go to the first cell where we want to start the copying, Control V, so our paste shortcut. Now this is an example where we copied and pasted these cells with formulas and it threw things off. See, it says Toledo-36133. So the easiest way to see what happened here is to double click into the Excel. Now we see that great highlighting with colors that Excel provides to us. Hey, we're starting, it turns out that the cell M is exactly 2 cells away to the right from cell K, and so it moved it from the home team to the away team, which is exactly what we want for this away team season variable. But we need to move this shifted cell back to the season column like this. And now that looks a lot better. For let's update the title here, the away team season variable, and we'll go ahead and update the title over here. Simply say the away team regular winning percentage. Okay, well this column M, the away team season column, looks great. Let's go to the bottom right, double click on that, let it scroll on down. Very good. Away team regular season winning percentage, similar to what we did for the away team season column. Let's double click and cell into, see where things are looking. Well, it is looking at the preceding column, the away team season column, to get that value that we want to look up. And notice that it is shifted again. The cells, the columns that are being referenced in the winning by team season worksheet. So that's the same worksheet that we were using for the home team's regular season winning percentage, and we can use it. It just has A teams in a particular season's winning percentage. We can use this for away teams and home teams. So we can still use it, but we still want to be referencing A as the lookup column and B as the returning value column. And so let's go into the formula here, and we can also edit it up here. Let's change this from C, just rolled over 2 to the right when we copied it, change that back to A, and change the return column from column D to column B like it was before. And that'll return for Toledo in 1998, 63%. Let's just do a quick check. I'm going to do Control C to copy that value, Toledo-1998. Go to the winning percentage by team season tab, Control F to bring up the find and replace menu, Control V to paste Toledo-1998. Let's search for that, click find next. There it is, 63.64%, and that's exactly what was returned. We've done our validation. It looks great. Only thing left to do for this column is double click on the bottom right corner, and it applies that formula to all the rows. Looks absolutely great. Now for our analysis, we don't just want to look at the individual percentages. What we'd like to understand is, okay, there's 2 teams that are playing each other. A lot of times in a postseason game, they're both teams that did really, really well, and so both winning percentages would naturally be high, or maybe some that barely made it into the postseason bowl games and their winning percentages would both be maybe moderate, maybe close to 50 or 60%. We want to understand the difference between the 2 teams that are playing. How large is that difference? So let's go ahead and create a column that calculates that. We'll call this difference in, and we'll use RS for regular season again, regular season winning percentage. And that, now we need to figure out what team's perspective we're going to calculate that based on. Remember, our home team won variable is calculated based on whether the home team won. From the home team's perspective, is it a 1 or is it a 0? Is it a win or a loss? So we should do the same thing here. So we'll start with it being the home team's regular season winning percentage, and subtract from that the away team's regular season winning percentage. In this case, the home team's regular season winning percentage was 27% higher, 27 raw percentage points higher than the away team's regular season winning percentage. And so it's positive. And we'll double click the bottom right corner here to scroll that down. Here's a case where the away team's winning percentage was higher than the home team's winning percentage. And so it's a negative from the home team's perspective. All right, well, this is good. Now, what we'd potentially do next is we need to do some kind of aggregation and say, in general, when this difference in regular season winning percentage is high or low, how does that impact the rate of the home team winning? But if we were to simply group by this column, it's a very granular column. 27.27 is going to be seen as different than, say, 28% if we had one like that. Those would be seen as distinct values, no aggregation there. We need to do some grouping so that we have more than just one or two games included in a specific raw percentage. We cannot do our analysis this granular of a level. And so we'll create a probably same category, same name, but let's call it category. We're gonna do some grouping here, and we'll do that grouping with an if statement. I'm going to start similar to our other functions with equals, and then we're using the if function. This is the same function we use to define whether the home team won or not. But this time, it's going to be a little bit more complex. We're going to do what's called nesting. So it starts out with a regular if function, and we'll say if this difference in regular season winning percentage is greater than, let's say, 0.25, which would be 25%. Even though this shows as 27.27 behind the scenes, if we were to convert this to a decimal format, for instance, we'd see that actually represents 0.2727. So greater than 0.25, if that's true, we're going to say it's a greater than 25% difference in winning percentage. Okay, so in this case, instead of returning a number like 1 or 0 like we did for the home team won variable, we're going to actually return a text label. And then that would be the argument. So remember how an if statement works. There's a test. Is this cell O2 greater than 0.25? And if it is, we'll return a text value in this case, because it's in quotes, greater than 25% difference in winning percentage. And let's say, we could do, if that's not the case, well, then it's less than 25% difference in winning percentage. But in this case, I'd like to have, what that would do is just return two possible values. I'd like to maybe group it by 3 or 4 different categories so we can kind of see if there's a consistent trend as we go higher or lower in the difference in regular season winning percentage. Does that make the home team more or less likely to win? And is there a consistent trend there? And so I'd like to have some more potential categories. In order to do that, we're going to nest if statements. What that looks like, we could have actually done that for the return true value, but in this case we say if this cell is greater than 0.25, return this value. If it's not true, rather than just return a specific value, we're going to ask you to execute another if statement. So we'll say if, we're nesting an if within an if this is now greater than 0, that's the test, and if that's true, then return maybe 0 to 25% difference in winning percentage. Why 0 to 25%? Well, obviously it has to be greater than 0, or else this condition wouldn't be true. But if it was greater than 0.25, it would have already returned this greater than 25% difference in winning percentage. So if it meets this criteria greater than 0, and it's going to return this value, it means it wasn't greater than 0.25, but it was greater than 0. If that's the case, that means it's 0 to 25% difference in winning percentage. And we're going to do a nesting again. Do another comma, and for the value if false argument, for this nested if statement, we're going to nest another if statement. If, and we'll go O2 here, if this is now greater than, let's say, negative 0.25, then we will give it a category of negative 25% to 0% difference in winning percentage. Okay, I'll put a percentage after this. Now, for our last argument, we'll say anything that hasn't been found to be true in any of the criteria so far. It's not greater than 0.25, it's not greater than 0, it's not greater than negative 0.25, and in other words, it's less than negative 0.25. In that case, we'll give it a value of less than negative 25% difference in winning percentage. This would mean the away team's winning percentage was 25 percentage points, raw percentage points, or higher than the home team's regular season winning percentage if it falls in this less than negative 25% difference in winning percentage from the home team's perspective category. Now, there's quite a bit of nesting going on here. So watch what happens when I try to close off the if statements function. I'll put a close parentheses there. Notice very briefly here, it highlighted the open parentheses to say you are closing off this particular if statement. I'm going to type another close parentheses, which closes off this if statement, and another close parentheses to close off this if statement, and that's the last one. So when I press enter, there we go. It looks good for this row. Yes, the difference in regular season winning percentage was greater than 25%. Now, what's going to happen when we ultimately group by this is it will naturally sort it in alphabetical order, and it may not be the right order. It might not be a consistent order where it has the greater than 25% first, and then the 0 to 25% after that, then the negative 25 to 0% after that. There's a few ways of handling that. One way could be to add a number or a letter in front of this. That's what we'll do in this case. I'll say something like A. I like to use letters A, close parentheses, and then I'll put this one B, close parentheses. This is just a very simple way to keep things sorted in the order that we want them to, since it's going to sort them by eventually when we do a pivot table, it'll sort them in alphabetical order. Putting these letters before each value is going to keep them sorted in that way. So now it has an A in front of it. And let's double click in the bottom right corner to scroll down. All right, 0 to 25%. Yep, 15, 16% falls in there. All right, our negative 17% falls into the negative 20%, 5% to 0% category. Let's see. Oh, here's one that's negative 33%. There's an example of column D. It looks good from a sanity check perspective. And this is great. We are ready to build a pivot table now. We're ready to do some aggregation. And again, in Excel, very popular way to do aggregation is to use a pivot table. Because right now, we're looking at 900 different rows. Now, we could go line by line. I wouldn't even call this an analysis approach. This would be anecdotal evidence. It would be to go through and say, did you know back when Marshall and Toledo played each other back in 1998, Marshall went into the game with a 91% regular season winning percentage. Toledo went into the game with a much lower 64% regular season winning percentage. And guess who won? It was Marshall, the home team. So the team that had the higher regular season winning percentage won the game. And therefore, when you have a higher regular season winning percentage, you're going to win the game. Right? And I guess, let's see, we have, here's another case where the home team Air Force had a higher winning percentage than BYU, and they won the game. And so all of these are anecdotes, right? Eventually we'll have something that disproves the theory, I would imagine. So yeah, here's a case where Texas A&M, home team, 83% regular season winning percentage. Well, Kansas State came in with 100%. So Kansas State had the highest regular season winning percentage between the two teams playing in this game. but the home team, Texas A&M, ended up winning. So that's an example that defies that theory. So what we need to do is not look at anecdotes, individual examples, but we've got about 900 examples here, and we want to see if our theory tends to be true in general. We know there's going to be exceptions. That's why the game is played. If we knew the outcome, they wouldn't need to play the game based purely on their regular season winning percentage. We want to understand if there's a general trend here. In order to do that, we need to do some aggregation across games. Now, we're going to do another pivot table here. I'm going to highlight, go to the top left corner to highlight the whole table, and then I'll go back to the Insert tab, Pivot Table, say OK. Great. And we're going to go to our rows again. We've got our starting table over here, our fields that we can choose from over here. We're going to scroll to the bottom. These are usually listed by default in the order that they were in the table. So the very last column that we created is at the bottom here. We want to drag that into the rows field. And there we go. We've got our 4 different values there. Now there's this blank here. We can actually exclude that blank by clicking the drop down or arrow, and we can exclude other values too, but I'll exclude those blank rows there. And notice it's sorted in this way because we included the A, B, C, and D for the order of our categories. Just a quick, simple way to do that. Now, what we're interested in is we'd like to understand what the winning percentage, the postseason winning percentage, was for each of these categories. And we have this variable, home team won, that tells us it's a 1 if the home team won that game, a 0 if not. Let's bring it into our table by putting it in the values space here. Again, does a sum by default. We want to change that to an average, which because it's a 1-0 variable, is going to represent the percentage of the time that the home team won. It's going to be interesting. There it is. All right, let's do some formatting. Left click on column B, right click, format cells, percentage. We'll leave 2 decimals. Look at that. Fascinating. Fascinating. When the winning team, or when the home team had a regular season winning percentage that was 25% or more higher than the away team, that home team won 76% of the time. Wow, that's pretty high compared to what you'd expect for a typical postseason game, especially. And then if the home team's winning percentage in the regular season was 0 to 25% in raw terms higher than the away team, the home team winning percentage was 64%, which is still somewhat high. It makes sense that wouldn't be quite as high as the greater than 25% difference because it's not as large of a regular season difference. So it kind of goes along with our theory. And then if you look at the cases where the home team's regular season winning percentage was between 25% to 0% lower than the away team's winning percentage, the home team still won more often than the away team. The home team won 53% of the time, even though they had a worse regular season winning percentage than the away team. That's kind of interesting. Maybe it speaks to their home team advantage. Maybe that home team advantage was driven by not their raw record, but perhaps there was some strength of schedule built into that as well. And it's true enough, they ended up winning a little bit more than average. And this is a very small difference between the two. I doubt it would be statistically significant, but we could do probably a difference in proportion test to assess that if we wanted to. But if the home team's regular season winning percentage was less than 25% of what the away team's was, the home team still wins 52.5% of those games. Fascinating. So in every category, the home team wins more, but you can see if we found that the home team, their winning percentage was more than 25% of the away team, they have an extremely high opportunity to win. Very interesting. Now, anytime you look at a percentage like this, it's also good to factor in how much volume there are of those circumstances. How often do two teams actually play each other and their regular season winning percentage was more than 25% different? Usually in the postseason you'd think similar teams are being paired up. So maybe this is driven by a low volume situation. Let's assess that. So one way we can do that, we just need to count any field that would never be null. So I think season's probably a good one to bring in here. It's going to sum the season by default, which is interesting. Let's go back to our tab. Oh, season is, season's a year, so that doesn't really have any intuitive meaning. Let's go to the drop down next to sum of season, and value field settings, we're going to change that to a count. There we go, and we should format this not as a percent, but format it as a number. So we'll get rid of the decimals. Okay, good. We can see that this 76% is actually only driven by 29 examples. Only 29 examples since 1998 in the postseason, two teams playing each other, and their difference in winning percentage was more than 25% different. And that makes sense. Again, that's probably how postseason games get created, is they're trying to match teams with a similar performance in the regular season. Similarly, on the other side of things, it's very rare that that scenario comes up. Plenty of cases here. So when I look at this, I'm a little concerned that it's interesting that these really extreme cases, there's a really high percentage chance of winning, but that's not a lot of volume. And so what I might do, just lots of different approaches here, but what I might do is go back to the postseason games tab, and I might update these categories to do something like maybe we lower that threshold so we have a few more games included in our top category. So if I lower this to say, well, let me know if the difference is more than 20%, and then I'll reduce this down to greater than 20%, and that would mean that this represents 0 to 20% now, and we'll make this, we'll say if it's greater than negative 0.20 as well, which will change this to a negative 20 to 0%, and this would be less than negative 20%. Alright, now we need to make sure we apply that to everything by now double clicking in the bottom right corner. Expand this. Okay, all cells are updated. Now if I go back here, nothing changed in the pivot table. This is important. You need to refresh your pivot table afterwards. So you can just simply right click anywhere in the pivot table, click refresh. I think it's because I have this filter here. Yep, before it was filtered on just those values. Let's deselect all, and we'll deselect the blank again. Okay. Very good. Well, our volume didn't really change too much, but we have a little bit more volume in our extreme cases here. So we have 54 in our greater than 20, 49 in our less than 20, and you can see that brought down the home team's winning percentage here, and it actually brought down, I believe, the negative 20. So maybe some of that 52%, it was just below the category above. The less than 25% category was negative 25% category was right in line with the negative 25% to 0% category, 53 versus 52. Well, now it's got a little bit more volume included in the categories. It's still somewhat low volume. I'm just going to go and do this one more time. Let's change this to a 15% threshold instead of the 20%. 0.15, 15, and then negative 0.15, negative 15%. we go. Make sure you double click the lower right corner, update that. And nothing changed until we right click on the pivot table, click refresh. Okay. Oh, I did not update this. There we go. Drag that down again. Right click, refresh again. We run into the same issue we did before. Just select all and then deselect the blank. Okay, this is good. All right, we've got a lot more volume actually. So the top category, if the home team's winning percentage was 15 percentage points or higher than the away team's percentage, we have 128 games where that was the case, and the home team's winning percentage was 67%. Well, this is interesting. Oh, actually, just discovered our ranking here is kind of odd. It did not rank it put D right below A. That, yeah, we don't want that. So how can we sort a pivot table? Well, we can click here, and I believe we can just say sort A to Z. There we go. For some reason it got sorted a little differently there. And now we have A, B, C, and D. Okay, 128 in our top category where the home team winning percentage was 15% or higher than the away team's regular season winning percentage. Goes from 67% to 63% if the home team's winning percentage was 0 to 15% higher. Then it goes to 54% from there if the home team's winning percentage was slightly lower, between 0 and 15 percentage points lower than the away team's winning percentage. That's based on a lot of volume. And then now in our lowest category, we have 100 games where the home team's regular season winning percentage was actually more than 15 percentage points less than the away team's winning percentage. And sure enough, in that case, the home team winning percentage is actually just under 50%. When I look at this, I see a consistent trend. It's consistently the case that for at least for these four categories, the higher the home team's winning percentage was relative to the away team, the higher the likelihood that the home team won that postseason game. And it's easy to see that based on this chart. Sometimes if you build something like this in a dashboarding tool, it's neat to put conditional formatting bars that actually will show you how this looks from a visual perspective within a table. Now, there's something called a pivot chart that we could do. We can also just simply graph this. And so in order to insert a simple graph here, I'm going to highlight this column that we want to graph. I'll do a bar chart in this case. Let's try a regular bar chart. And this actually is this appears to be a pivot chart. Yep. Turn it into a pivot chart because I'm basing it on a pivot table. And I'm just wanting to check something. Okay, notice that the count of the season here is dominating the chart, and then you have the average of home team win, which is really the winning percentage, that the home team's winning percentage that just hardly even shows up on the graph. They're on the same axis here, so this is not a great graph right now. Let's change the chart type. One perfect thing we could do right here, this is a perfect opportunity to use a combo chart. So I'm going to go to the very bottom here. What this allows us to do is for volume related things like the number of games that something is based on, which is in this case is called count of season, we'd want to rename that. But that's good. That's a good thing to show as a bar. And then what we can do is show a line on top of that. And a line's really good for showing a percentage over time or across groups. Now, again, you can even see in this preview here, the average of the home team winning, the home team's winning percentage just gets washed out by the scale of the number of games, the count of the season variable. So what we can do is mark secondary axis on one or the other. Doesn't really matter which one. And now there will be two different axes. Let's just take a look at what this looks like. Whew, that's a lot better. This is nice to see. This is the visual aspect where we can see, when the difference in winning percentage is high, the home team's likelihood to win that postseason game is higher. And then as that regular season winning percentage between the home team and the away team goes down, the likelihood of the home team winning goes down. It's a consistent trend. It's not like you see, it goes up for this cat, in this particular group, and then down and then up again. That's not a consistent trend, right? This is much more consistent. Now, eventually, we can take that to the next level by applying some statistical tests, maybe some statistical models to see if that holds true, and what the p-value associated with it, what the likelihood, really calculate the likelihood that this trend is due to random chance. So eventually we'll be able to do that. But for now, this is great to see. And we might, let's see, don't know if we can rename the columns easily in our pivot table. We'll try number of games. Oh, we can. Winning percentage. There we go. That's good. Now it's good to also include titles here as well. So when we go into, you can see when we click on the chart, we go into design, definitely add a chart title. And I'd call this something like home team winning percentage by regular season, let's see, winning percentage differential. And I might also, I want to clarify what this difference in winning percentage represents. I'd go into, again, clicking on the graph, so it makes this menu available under the design tab, add chart element, and we want to do axis titles, and this would be the primary horizontal title, and I would call this difference between home team. We'll just use RS for abbreviation for now, might not be ideal. Difference between home team regular season winning percentage and away team regular season winning percentage. I'm going to probably be a little more brief there, but that's good. And another thing that stands out here, though, is the fact that we have 2 decimal points on our axis when it's counting up by tens, 10% at a time. Those 0.00 percentage is not necessary. This gets on a lot of folks' nerves when they see graphs like this. I've heard that before, so I will right click on this and I'll say format axis, and that'll bring up this menu on the side, and it will allow us to go to number option, percentage, and we'll want to remove the decimal points there. And we can also adjust if we wanted to have this go up to 100%, for instance. Not that we necessarily would. We would just update the maximum and minimum values, and that made it go by 20s now, and we can change that here if we want it to go by 10s instead. Yeah. All right, but there you have it. We've got a pretty nice chart here. There are going to be some additional opportunities to clean it up, but that's a pretty good chart that you might be able to copy and paste into a PowerPoint for your presentation. Now, we have an entire session dedicated to data science modeling, but maybe we get a sneak preview of that right now because we've got a really interesting use case here. We want to assess whether the regular season winning percentage performance can be used to predict who ultimately wins this postseason game. And we have done some regular data manipulation. We've done some grouping, some merging. I will say we had to do a lot just to get this table. And we'll have to do even more to build a statistical model to assess whether this trend is statistically significant. In SQL, in Python, in an analytics coding tool, this whole thing could have been done in a single query. And that's just an example of how you can really take your efficiency to the next level if you're using primarily Excel today, and you take that leap to learn something like SQL or Python. So I hope you'll watch our videos on SQL and Python to do just that. But let's show how we can do the same analysis. We have some good evidence based on this table that there is truly a trend here, but let's really see if that's statistically significant. Now, right now we've been analyzing the winning percentage, and the way we've posed the question so far is, what's the likelihood of the home team winning that game? And we could model our create our model based on that, based on whether or not the home team won that game. Go back to our postseason games tab here, and we've got this home team won field. And if we were to do that, we would use something called logistic regression. It's a form of regression that is tailored toward binary indicator variables. They won or not, they bought or not. But there's also some downsides with logistic regression, mainly the independent variables, the coefficient that gets assigned to them. It's a little less intuitive. It's predicting the log odds, and so that coefficient assigned to it ends up being less intuitive. And in some cases, you can actually build a model on a binary indicator variable and use the more simple linear regression for it. And you might do that to get a more interpretable coefficient. That's especially okay, or not as bad, I would say, compared to using logistic regression for a binary indicator variable, if it's close to about a 50% ratio, 50% being 1, 50% being 0. It's not as bad to use linear regression in that scenario. You still ideally use logistic regression, but it's not as big of an issue. Now, if you're dealing with a 1, 0 variable, and it's the case that maybe it's a fraud use case, and 99% of the time it's a 0, and 1% of the time it's a 1, you really need to use logistic regression in that case. You don't want to use linear regression. Don't even consider it in a situation like that. Just sign up some quick tools or quick rules for you when you're faced with a situation like that. But you use linear regression, generally it's recommended for a continuous, normally distributed variable. And actually, we could easily get a variable that is continuous and probably normally distributed as well by, instead of looking at whether the home team won or not, looking at what the point differential was between the home team and the away team in that postseason game. All right, so let's try that. I'll just go ahead and insert a new column. I don't think we've done this yet, insert a new column, but it works the same way as inserting a row. You just highlight the column that you want to insert that column before, right click, say insert, and we have a new column, and we'll call it home team point differential, and it will be equal to the home points minus away points. Easy enough. There we go. So all of these games were won, and so it's positive. Here's a game where the home team lost by 7 points, and so it's -7. Looks good. Now this is going to be more likely to be normally distributed. It's a continuous variable. It's not just a 1 or 0. So this is a pretty good use case for regression, for linear regression. And so we'll use that as our target variable in the model. And what we'll do is see if we can predict what the home team point differential is, if it's negative, if it's positive, with our difference in regular season winning percentage variable. We'll see if there's a correlation between these two, and if it's statistically significant or not. Now, another neat thing about looking at the home team point differential versus the home team won variable is this has more information. If a home team really blew it out of the water like they did in this game, beat the away team by a lot of points, then it's going to count for more than if they just barely squeaked by 2 point win here. This will count for more then a 2-point win. A 2-point win will basically be considered close to a tie compared to this 27-point win, and vice versa. So there's more information captured in a variable like home team point differential. And you know, that may or may not be a good thing. I think in general that's probably good to have that more information. In some cases you could have some extreme outliers that talk about how to handle that again in our data science training eventually. But maybe you have a case where a team won by close to 100 points, and that game is just going to count a lot when we look at the relationship. And we may not want that to be the case. We may say, oh, that outlier is really driving our results more than we'd like it to. And when you just look at it from a 1-0 perspective, a close to 100-point win is considered a 1. A close to 100-point loss is considered a 0. It's considered the same as a 10-point loss. So it automatically kind of caps the impact of outliers when you look at it from an indicator variable perspective. So there's some pros and cons there. It really comes down to what you're trying to measure. Okay, well, we want to build a model in Excel. Now, by default, I don't think the regression option is available, although there could be some formulas for regression for calculating certain coefficients. But what we want to do is use a very easy to use regression function and regression option. And the way to do that is to turn on the analysis toolpack. That's the first thing we need to do. So let's go to the file menu up here, then go to options. It's going to bring up this menu, or actually you may not be able to see the menu on my screen, but what you should see is a menu pops up, and I want you to click add-ins next. And then you should see something, perhaps if you don't already have it, if you already have it installed, it should have a section that says active application add-ins. And it will say analysis toolpack below that. If that's the case, you should already be set up. But if it's not, look under inactive application add-ins and go ahead and activate analysis toolpack. All right, so we've got it activated here. What I'm going to do on my postseason games tab, we're going to go to the data tab, and then we're going to click on data analysis. This will only be available once you've activated the analysis toolpack in Excel. Click on that. All right, we've got quite a few options here. The one we want is regression. I'll just click OK there. And it's going to ask for our input Y range and our input X range. So the Y range, this is sometimes called the dependent variable or the target variable. Our target variable, what we're trying to predict or explain in this case, is the home team point differential. So we can simply highlight column K for that. And then our X range is going to be the variables that are input variables, our predictor variables. And that, we only have one in this simple example, and that'll be the difference in regular season winning percentage. Great. Now, by default, it is going to include a constant, which is good. It's kind of similar to a y-intercept, a starting value. What's the predicted point differential for the home versus away team if the difference in regular season winning percentage was 0? Is what the constant will represent. So it'll have a constant because we don't have constant 0 checked. We'll have it go to a new worksheet. I think we can click OK here. Input range contains non-numeric data. Okay, so that might be what we might need to do. Is select just, we might need to skip over the titles. So unfortunately here we might have to go all the way down. I think we can do our shortcut Control-Shift-End after selecting the column. It's going to the end of the table. Just update this to be only K. Alright, let's do that again. Highlight all of this. we'll go to column K here. I'm just going to scroll all the way down in this case. You know, you could also kind of figure out how many, scroll to the bottom outside of this, see how many rows there are and populate there. Lots of ways of getting there. But there's our K 2 through 892. And then we'll do the same thing, copy that same kind of text and just update it to be column P, since we know that's where our input variable is. That's where our regular season point differential is. Oh man, it's kind of, maybe I'll just start by doing the same thing here. I'll just highlight it, row 2 through 892, column P. Okay, now I should also mention that I believe Excel and most other platforms like SAS and R and Python, depending on the algorithm you're using, most of them will not run if you have any null target values or any null non-value, any null input variables. It just won't run, and so you have to handle missing values. In this case, I don't think we'll have any missing values. We'll see, but we'll talk more about different ways of handling that in our data science modeling session. Click OK here. All right, we've got a new worksheet. That's a good sign. And there's our regression output. It's kind of standard regression output. We'll see something very similar in Python from a regression output perspective, at least when we use the stats models package. A few things that I will highlight here. We'll talk more about this in our data science training session. First thing is our R-squared value, which is quite low. This is the percentage of variation in the point differential from game to game that can be explained by our model. It's telling us that only about 1.5% of the variation in terms of why one team wins by 50 and another time the home team wins by or loses by 25, let's say. Only about 1.5% of that can be explained by our model. There's a lot of variance, and that's why the game is played. There's other factors too, and this will relate to one of your homework assignments. But I'm going to come down here now and look at the individual variables. The first one is the intercept, and the intercept in a regression model represents what would we predict the point differential to be. The target variable in this case is the point differential, the home team's point differential above the away team in the postseason game. What do we think that would be if all the other input variables in our model, in this case it's just the regular season home team winning percentage versus the away team percentage, if that were 0, if all the input variables were 0, again, in this case there's only one, if the home team's regular season winning percentage was the exact same as the away team's regular season winning percentage, if that were the case, on average, what would we predict the home team's point differential would be above the away team? And this tells us, this is very intuitive, 2.85 points on average. So you could call that the home field advantage, which is kind of a unique situation when it comes to postseason games. It's not necessarily being played at that team's stadium, but perhaps it represents the extent of at which, like, why that team was designated the home team versus the away team. So there's something else about their past performance that causes that home team to do better than the away team, and maybe there is somewhat of a home field advantage or closer to that area than the away team. So that tells us on average the home team is generally going to score 2.85 points more. If you take out, if they had this, the two teams had the same regular season winning percentage, but then if they did have a difference, what this essentially would say is if the difference in an extreme case, let's say, was negative 100%. So the home team for some reason won 0% of their games, the away team won 100% of their games. That'll be a negative 100% point regular season winning percentage difference from the home team's perspective. Well, you take that would be a -1, a negative 100%, of corresponds to a -1 value. You take that -1, multiply it by 16, that would be -16 points that we expect because of that large of a difference in regular season winning percentage. But it is the home team, so they'd still get this 2.85 points that we expect because they're the home team. We'd add those together and come out to maybe close to -13, -14 points differential expected for the home team. We'd expect them to lose going into that game by 13 or 14 points on average, just based on this simple model. On the other hand, if the home team had 100% regular season winning percentage and the away team's regular season winning percentage was 0%, again, the most extreme case, that'd be a difference of 100%, really a difference of 1 from an Excel perspective. So 1 times this coefficient 16 would say, okay, because of that regular season winning percentage differential, we expect a 16-point lead for the home team. And because they're the home team in general, we're going to add to that this 2.85. So by the time we do that, we're looking at maybe 19 to 20 point advantage. We expect the home team to win by 19 or 20 points in that extreme situation when the home team did much better than the away team. And it's a very simple model, but hopefully that gives you a really high level overview of what you can do with regression. Now, all right, one more thing that I should do before we move on. The whole point of building this regression model was not just to assess what the overall impact is, but this does a nice job of summarizing that, what the impact of these things are, being the home team, that regular season winning percentage differential is on average. But then we also have this p-value, and this is a really low number. It's showing scientific notation here, which is like 0.00056001. So a very small number, and even the p-value on it says x variable 1 here. We know that that represents the regular season winning percentage differential. Even that one is a really small number. What this represents is the likelihood that this coefficient was generated due to random chance, that there actually isn't a relationship there. And the likelihood of that being the case in this case is like 0.0001. It's really low. It's a very low likelihood that this was due to random chance, which means that it's very likely that there is a real trend here. It's truly the case that the home team on average has a higher likelihood of winning than the away team, and that the team that had the better regular season winning percentage has an advantage as well, that there's a relationship there between their regular season winning percentage differential and the team that wins the postseason game. But bringing it back, so we're very confident that those trends are true on average because of this low p-value. But bringing it back to the r-squared, which talks about the overall predictive power of the model, yes, these trends, we're very confident that they're true on average, but when it comes to predicting an individual game, even these two variables, they can only explain 98.5% of the variation. They can only explain 1.5% of the variation. There's still 98.5% of the variation that is left unexplained. And again, that's why the game is played. There's so many cases where the home team doesn't win, where the team that had the worst regular season winning percentage wins the game, that defy our model. There's plenty of cases that do that, and that's why this r-squared is so low. Hopefully you got something out of this. Hopefully this spurs some ideas for additional analysis to do. This is just one way you can take this data set. There's all kinds of other statistics and analysis and modeling to be done on a college football data set like this. If you've ever thought about becoming an investment banker, this next Excel demo is for you. We're going to take a lot of the concepts that we covered in the personal finance demo, but this time apply it to a company that's considering making a particular investment in a way that an investment banker might use to sell a company on why they should pursue that investment and how it would impact their income statement and balance sheet if they made that decision versus not. It's another good example of how setting up inputs that can be changed can automatically update the rest of your model in Excel, which is a way that Excel is unique among the data analytics tools we're looking at. So let's do some financial modeling in Excel. All right, here we are back in Excel and we're ready to do some financial modeling. Again, a great use case if you've ever thought about becoming an investment banker. Our scenario today is we're performing an analysis for a golf company that sells drivers and perhaps other irons as well, certain types of golf club, but we are considering buying a company that sells putters, and the investment bank or the company themselves thinks that there could be an opportunity to see some synergy here. We could potentially combine forces, produce things at a lower cost. We could boost our sales, and we want to see how that would impact both our income statement and our balance sheet if we made that decision to invest and buy this putting company, or if we didn't. What would the difference be in different areas of our net income and our balance sheet, different aspects of our balance sheet? So we're a golf company that sells drivers, considering buying a putter company. That is our scenario. And so what we'll do today is build this out. We're going to build it out from scratch. So I'm starting with a brand new Excel workbook. Go ahead and open that up. And what we'll do is this time, it's going to be very similar to the personal finance use case, but this time we're going to spell out our inputs to our model at the very top. So our inputs will be things like, what is our standard annual sales growth going to be? Just what do we expect sales, how do we naturally expect our sales to progress over the next years on average if we weren't to do anything differently? And then we'd need to maybe have an input for our current gross profit margin. It's the percentage of our overall top line revenue that we would actually get to keep after removing the cost of goods sold. So we'll have that as a variable here. Let's also create a current, sometimes you see the line item in income statements, selling, general, and administration percentage. And this will be a percentage of revenue. Let's make that clear. Put an extra period here. Another input that we'll look at is the interest rate that we get. We'll actually have a separate interest rate for the interest rate on cash, which might be a money market rate, so very liquid asset rate, and then versus maybe an interest rate on other assets. And then we'll also do a tax rate here. Let's call this a... All right, so those are our inputs. I'll double click the right edge of column B to expand it so we don't have any cells getting cut off. And then let's also populate what the actual values are. So we'll assume that our sales are expected to increase year over year over year, about 4% year over year on average. And our gross profit margin we'll say is 40%. To keep 40% of the revenue after accounting for the direct cost of goods sold, the cost to make drivers and irons. Then our current selling general administrative percentage, let's say that's about 15% of our revenue in total. Say our interest rate on cash, we'll use kind of a high rate of 6%. And then our overall interest rate on other assets, let's say is 8%. Say our tax rate is 25%. And there we go. We've got our inputs. Let's highlight them in yellow. If you use any color for that, let's center this. I'm going to go ahead and go to View, turn off grid lines, and we've got a good start here. Now that we've created our list of inputs, let's go ahead and start creating a no change scenario. And so maybe a few cells down, I'm going to call this no change scenario. And eventually we'll create a with change scenario over here. For now, we'll just call this no change scenario. And let's say we're going to forecast out for several years, starting with 2023 and beyond. And so I'll do that here. Very similar to the personal finance use case. I'm going to make this dynamic where I just reference the cell in the previous column and just add 1. I can drag that formula over. We'll go all the way to 2032. Again, we can highlight these and see that that's 10, delete 2023. I'll center these. Now the first statement we're going to look at is the income statement. I'll actually insert a few rows above this, right-clicking, insert, and call this the income statement area. Income statement. Might really want to highlight this. So I'm similar to what we did with the expense section and the income section. I'll bold this, put a border around it, and I'll color it green. Income statement. And I also kind of do the same thing here. In fact, I might use the format painter here, format this no change scenario, maybe give it a different color. And there we go, we have our no change scenario. Now we're going to need to do some labeling coming up. So this is going to be our section for our line item labels. The first item we'd have on the income statement is our revenue, and so we might create a whole section for revenue potentially. I'll do that over here. Call this our revenue section. Merge cells, put a border around it, maybe bold it as well, revenue. And then below that, our first line item, actually our only line item for revenue. You can feel free to update this and change it to whatever scenario you think works. But we'll do sales, and that'll be just our only revenue generator. We won't split it out any more than that. Similar to personal finance, you can get as granular as you'd like. Maybe you split sales out by different types of sales or categories of sales. But in this case, they'll all be one value. And I guess to start, we need to come up with a starting sales amount, and maybe that could be a parameter in itself. So I'll go back up here and insert another parameter here. Let's call this our starting sales value. Maybe we do, let's do maybe 200,000. That'll be our starting sales value, and we'll make that yellow as well since it's an input parameter, which means down here we simply point to that, 200,000. And similar to how we expected our income to have a 3% increase year over year, each year on average, in our personal finance example, formula will be very similar here. We'll reference the prior cell, multiply by 1 plus this expected 4% annual sales growth. There we go. We'll drag this to the right, and we have a sales forecast. It doesn't look right. This 2024 looks okay, 208,000, but then it stays at that level. Made the same mistake that we did in personal finance where we didn't lock the cell in, so it continued to drag over here. Now again, if we had a different expectation for what that annual sales growth was going to be year by year, that would work just fine. We'd need to populate it. But in this case, we just have a general expectation for the next 10 years. It'll increase on average by 4%. And so we want to lock in that cell. I'm going to use the F4 shortcut to lock in both the column and the row. Really, we just need to lock in the column, especially in this case. Drag over. That looks a little better. Got a good sales forecast year by year for the next 10 years. Looking good. Well, the next thing we want to do is have a cost section, and I want to have a kind of a section label similar to revenue here. So I'm just going to copy that, paste it in the first cell where I want that to start down here, and then I'm going to call it costs. And the only line item here, and you could get more granular, is going to be cost of goods sold, and that will be a simple formula. It'll be our sales times, and then in parentheses, to denote the order of operation, we want to do 1 minus what our gross profit margin assumption is of 40%. Okay, so that'll be our cost of goods sold. Looks good, looks good. So now from here, we can use kind of an underline operation. For spacing reasons, I'm just going to put the underline. I'm going to skip a space here, and I'll put a bottom border here to denote the fact that in this case we're doing a difference. It's very common, again, to use a line to represent a sum or a difference. So we're doing a calculation here, and the calculation is to calculate the gross profit, and that is simply the sales minus the cost of goods sold. Drag that over. So what we've been doing so far is clicking in the bottom right corner and dragging down. You can also drag over. Something doesn't look right there. Okay, that calculated just fine. What happened here? It looks like the problem was with our cost of goods sold. Let's check that. Oh, the locked cell got me again. All right. Important to apply sanity checks to check your work, and that's kind of what we're doing along the lines. We're looking for things that look out of place. This $0 definitely looks out of place. I'm going to double click in here. 1 minus the 40%, and we've got to lock in that 40%. I'm going to click F4 as I've highlighted. I have my cursor on C7. Great, that should be a little better now. There we go, there we go. So we expect our gross profit to go up over time. We expect our sales to go up over time. Looking pretty good overall at this point. Let's do the same thing and start to create another section for operating costs. That'll be the next thing we kind of subtract out. Call that operating costs. And that is where our selling, general, and administrative costs come in. And that'll be a percentage of our revenue. 15% of our top line revenue will be assumed to go toward selling, general, and administrative cost. I'll say equals sales times 15%. And this time, I'm not going to forget to lock the cell. Click F4, and there we go. We've locked it in. Drag that across, and we've got our selling, general, and administrative costs all plotted out by year. Looking good. And now we're able to do another calculation. So I'll highlight the cells above which I want to put this bottom border. Select that. Got a border here, and this will be our earnings before taxes, really before taxes and interest as well. Great. So I am going to, the earnings would simply be, here's what we brought in, our top level sales, subtract out the cost of goods sold, and subtract out the general administrative. Actually, we've already done this calculation of the sales minus the cost of goods sold. That's our gross profit. So we'll start with that. Equals the gross profit minus your selling, general, and administrative cost. Did equals there instead of minus. Drag this over. Great, we've got our forecasted earnings before taxes and interest by year. Perfect. Well, the next section, now that we've calculated that, is to have an other revenue and expenses section. And this will include our taxes and different forms of interest earned and paid. So we'll call this our other revenue and expenses section. There we go. We'll have 3 line items here. First being interest earned, interest paid, and taxes. Depending on how the company sets up their income statement, there could be different line items in any of these sections, but that'll be what we use for this example. So those 3, and then eventually we'll be able to take those 3 and do a sum of them. We'll go ahead and get that ready. A sum of them to get our total expenses for that section. But then we would take those expenses and we would subtract them from our earnings before taxes and interest to get our net income. So we'll go ahead and set up all of those sections here. Our interest earned is going to be a function of, one, what our interest rate assumed is, which is over here. But the other thing is actually going to come from our balance sheet, which we'll create below. We haven't created that yet, so this is something we'll come back to because we're going to want to point it to whatever our balance was, similar to how we calculated our return on savings in our personal finance example. Interest paid, also a function of what our long-term debt was, which will be on the balance sheet that we create below. So we're not ready to populate that either. Now taxes, we can populate. Let's say taxes are a function of our earnings before taxes and interest, and then we would want to, in reality, have different taxes perhaps for capital gains versus your regular income. But in this case, we'll consider everything together. We're simplifying here for this example. So we'd say earnings before taxes and interest. We want to add the interest earned. That'd be considered maybe revenue as well. Again, probably tax at a different rate. Simple example. And then we'll subtract out our interest paid. Eventually these will be populated. We're preparing, assuming they'll be populated here. So that would be essentially what we need to pay taxes on. So we would take that, put that in parentheses. We want to do that computation first, and then multiply by our tax rate. Not going to make the mistake of not locking in the cell. My cursor's on C11 here. I'm going to press F4, locks it in with the dollar signs. Great. There we go, 12,500. Now, if this were negative for some reason, let's say our gross profit margin was a little bit lower. Let's say it was more like 10%. And we actually have a loss. This would suggest our taxes are negative. That doesn't really make sense. So let's apply, we're going to use a function here. We can use we kind of want to say, okay, whatever the maximum is of that computation of what our taxes would be, or 0, which will, if your calculation ends up being negative taxes, I'll just replace it with 0. And that's what happened here. I'll change it back here. I just wanted to show that as an example, or go back to a profitable company with a 40% gross profit margin here. And there's our 12,500 tax amount. Now, in reality, sometimes tax credits can get carried over to the next year, so perhaps it wouldn't be as simple as putting in a max statement there, but we'll just assume that, all right, if you don't make any money, you don't get taxes, and then the next year if you make money, you start paying taxes on whatever you made that year. Just very simple example. And to calculate our net income, we would say, well, here's our earnings before taxes and interest. Let us add to that the interest earned. Let us subtract from that the interest paid. And let us subtract from that our taxes. And there we have it. Now we still need to populate these two, but for now, without any interest earned or interest paid, we'd have a net income of 37,500. We need to drag over both of these formulas. We'll worry about interest earned and interest paid after we populate the balance sheet, but let's drag this over as well. And hey, we've forecasted our net income over time. That's pretty neat. Now it's time to put together a balance sheet for this hypothetical corporation. I'm going to scroll up to the top here, and we have a label here for our income statement. We want to bring that down, and probably the years as well. We'll copy and paste the years too in this case. I copy that entire section, scroll down. I have a long Excel workbook in this case, and let's call this the balance sheet. I'll give that a orange color here. Perfect. And now let's just go ahead and set up our labels for starters. The first section here will be called, well, we kind of need a global section first, and that'll be our assets section. Assets. There's really three sections primarily on a balance sheet. There's your assets, and then I'll list those out, and then eventually we'll get to our liabilities, things like debt, assets, things like cash and property, liabilities, and then equity. And there is a classic formula in accounting and finance, and that is assets. Your assets equal your liabilities plus your equity. So we'll need to make sure those two things ultimately tie out. Let's talk about some of the assets we might have in an example. Every company will look a little different here, but first there's current assets. Those are more liquid assets. So we'll give that a label here. Now this could come into play for, it's a technique you could use for all kinds of Excel spreadsheets, but especially financial ones. I'm going to insert a column before column C here. So I'm highlighting column C, right clicking, insert. Watch this. I'm going to take this left side of C to kind of make B a little bit smaller. Just want a slight indent is kind of what I'm trying to do here before our actual year columns start. And now I've created a place where I can add sub-current assets, things like cash, and I'll do accounts receivable, money that maybe our customers owe us that we haven't gotten paid yet, so it's not cash, and maybe we've got some inventory, golf clubs laying around, and then we have fixed assets too. Those are kind of more less liquid assets. So fixed assets, and maybe we have things like land. Maybe we've got some equipment we use to create the clubs, and depreciation. Very good. And then we'll create a placeholder for total assets where we'll add our current and fixed assets so we can see in one column, one row, what all of that adds up to. And make sure that it ties out with our liabilities plus equity, because again, that is a formula that needs to hold true in accounting. I'm going to delete an extra row here. And well, maybe we'll start just populating this for now. Our current assets will ultimately be simply the sum of our cash, accounts receivable, and inventory in this case. I'm just gonna highlight these cells, and you can see it uses the colon to say all the cells between these two. We want to sum those, and I will drag that to the right. I'll center. I just realized, let me scroll up here. Okay, good. We're using the dollar format up here. We want to use the dollar format down here as well. Maybe I'll save that to the end to do, but eventually we want to format these as dollars. Cash. Ooh, cash is an interesting one. Now for the first cell, we should probably have some kind of maybe a starting cash value, and that we will set as a parameter at the top. So let's scroll to the top. Just put it before starting sales value, starting cash value. Let's say we start with maybe 150,000 here. Highlight that as an input. Great. We'll just simply point to that. I guess similar for probably all of these, we might want to set them all up as inputs at the top. So we've got our account receivable, inventory, land. I'm just going to go ahead and scroll to the very top here, and let's paste them here temporarily. Create some additional rows, some space to put all of these parameters. These in the first, maybe move some of these things around. I'm going to do Control X to cut, Control V to paste. Same thing with this, Control X to cut, or we could right click and highlight all of them and right click and say cut, and then right click here and say paste. Manual way, non-keyboard shortcut way to do it. All right, so we have those labels set up, and now for accounts receivable, we'll say we'll start with $5,000 in accounts receivable. Maybe we do $10,000 in inventory. Let's do maybe 200,000 land. We'll say we start with 100,000 in equipment and 75,000 in depreciation. I'm going to highlight all of these. These are just made up numbers. You can make your own assumptions here, and the great thing about parameterizing them is at the top is you can change them here if you want to, and everything else is linked. We'll update from there. So I might left align all of these. There we go. All right, now we come down to our balance sheet section, and we simply point account receivable, row 60 for me, to starting account receivable, point inventory to our starting inventory level, come down here to fixed assets, point land to land. Now we have these in the same order, so land, equipment, depreciation, so technically I can now drag this down for equipment and depreciation, and that looks good. I'll go ahead and get everything centered here. I'm going to scroll back up. I noticed that this is not dollar format. Now I could right click and change the format that way. Format cells, can always do that. Or I can just find one that has the format that I want, like this one that has dollar signs, format painter, click on the cell that I want to have that format, and there we go. So that looks good. Now I forgot to add starting in front of these, and I think that would be helpful to denote that these are the starting values, basically what the values were at the beginning of 2023. Go ahead and save. Scroll back down. All right, looking good. I'm going to go ahead and update the format of this 165,000 now using the format painter. Looks good. Fixed assets, similar to current assets. In fact, in this case, we could just Control C, copy that formula, Control V, and it's just doing the same thing. It's summing the three rows below it. So that works out very well. And our total assets would simply be our current assets plus our fixed assets. Easy as that. It adds up to 540,000. Looks good. Let's see here. For our accounts receivable and our inventory and even our fixed assets, I'm not going to assume that these change much from year to year. We're going with a really simple model. I wanted to include them here because those are typically seen in a balance sheet, but I'm just going to assume that these stay flat. The 5,000 stays relatively flat year after year after year. Maybe it's different customers that owe us year after year. Hopefully things are being paid and new lines of credit are being opened up. Similar with inventory, drag that over. And I'll just make the same assumption with land and equipment and depreciation. I'll just assume that all of those things are staying relatively constant year after year, especially in our no change example. And I'll drag that over, which will always be the sum. Cash is going to be an interesting one. I'm going to come back to cash. That'll be a plug number essentially. Eventually, go ahead and center all of these up. Yeah. Okay. Gonna just apply that formatting here. There's another one, inventory here. I'm gonna update that to have a $sign in it. All right, our asset section is looking pretty good right now. Now it's time to move on to our liabilities section. And similar to how you have current assets and fixed assets on a balance sheet, you'll usually have current liabilities, which would be your more short-term liabilities. So we'll have things like accounts payable and maybe deferred income. So accounts payable, money that we owe maybe our vendors, and deferred income would be money that maybe has been paid to us already, prepaid to us for things that we haven't delivered on yet. So it hasn't been recognized as income yet. So that'll be our current liabilities there. And then we'll have some long-term liabilities, like maybe we have some long-term debt here. So that'll be our only long-term liability value in this example. I'm going to insert some space here to also create a total liabilities line item. Current liability simply going to be the sum of these two rows, accounts payable and then deferred income. Go ahead and drag that across. Now our starting, here again, we need a starting accounts payable value, a starting deferred income value, starting debt value. I'm going to copy these titles up here so that we can easily add them in. Just 3 more rows for these. Doing Control X, Control V again. All right, what do we want to use as our starting accounts payable value at the beginning of 2023? Let's say our accounts payable and what we owed to our vendors, $10,000. Let's say we had about $5,000 in deferred income at the beginning of 2023. Let's say our debt was $100,000 at that point as well. Left align, highlight, keep your formatting consistent. That is so appreciated by your stakeholders, anyone using this. It's just easier to follow when formatting, coloring, alignment is consistent. All right, so we're going to point to our starting accounts payable value. I can drag down for deferred income, and then I'll go to the debt line here, point that to the debt line here, our parameter 100,000, and I just realized we need to add starting in front of these as well. Like we talked about in the personal finance example, creating parameters at the top is not just limited to Excel. It can apply in SQL, and it definitely applies a lot in Python, setting variables and then referencing those variables later. It's a great practice. Very easy to find anything you would want to update at the top of your code, at the top of Excel. It's a good practice. Okay, this is looking good. Now, let's see here. Similar to our current assets, most of them except for cash, we're going to try to keep these consistent. Our accounts payable, our deferred income, our debt, we're going to just assume that those stay pretty constant. That won't be the focus of this exercise. In real life, if you felt like that was a bad assumption, you could update that. our long-term liabilities in this case is just equal to debt. That's our only line item. You could add more if you wanted to. I'm going to need to update our format of our current liabilities. Our total liabilities will simply be the sum of the current liabilities and the long-term liabilities. Drag that to the right. Then we'll center everything up. Okay, that's looking good. Now, let's put a line between here. Since there's a lot of cells being added here, let's just go ahead and put a line that denotes that there's some math happening here between adding the current and long-term liabilities. Similarly, up here, insert another row. Let's put another line below here to denote that this total assets equals the sum of current assets and fixed assets. And I think that's looking pretty good. Now there's one more section, the balance sheet, and that is the equity section. Okay, we've already put space for equity. The first line under equity might be paid in capital. And that I guess would be fairly constant unless the owners are taking money out of the company. So we'll say at the beginning of 2023, our paid in capital, it could have been paid in years ago, but we're starting everything here. We're showing 2023 and beyond. Say that was 20, well, here again, let's create that as a parameter at the top. So maybe we'll do that. But then we'll have retained earnings. You know, what did we earned? What was our pool of earnings beyond just our paid in capital? What was our retained earnings at that point? And then let's also capture what our current year earnings were. And when we sum all of those up, that will equal our total equity. And then we'll have another line item down here for total equity, liabilities and equity added together. Because remember, the sum of liabilities and equity equals our total assets. So we'll want to make sure those line items tie out. Okay, so we'll go ahead and copy these to the top. Retained earnings is going to be unique. We'll come back to retained earnings here. But current year earnings, actually, that'll be a calculation. We'll simply be pointing to our income statement. So the income statement and the balance sheet, they influence each other. Again, we're going to have to calculate interest earned and interest paid based on balance sheet fields. And then some of our balance sheet things, like our current year earnings, we will actually be linking to this net income cell here. So they work together, the balance sheet and the income statement, they influence each other year after year. We'll be able to drag this across to capture our current year earnings. We can go ahead and just do the math here, adding up all of our 3 line items in the equity section to get our total equity, and then adding our total liabilities to our total equity to get our total liabilities and equity. Might as well. And we'll just drag those over. Yeah, looks good. I'm going to copy this formatting for now. We still need to set our initial paid in capital parameter. Just paste that here. Insert another space. It's good to have some good spacing in your Excel workbook or presentations as well. Paid in capital, we'll assume that starts in 2020, at the beginning of 2023. Our paid in capital was 25,000, let's say. And I'll highlight that yellow and left align. And we will point this at 25,000. Great. Now this is another thing. We're going to assume that we are not adding in capital or taking out capital from the business, and so this will remain constant as well. For simplicity, center everything up here. Okay, so retained earnings. In order to calculate what our retained earnings were at this point, technically we have this formula around assets equals liabilities plus equity. So what we should be able to do for this first year for retained earnings to figure out what number would make sense here. Maybe we have the number and we could plug it in. In this case, we want everything to make sense. So we're going to say, we're going to start with our assets, and then we're going to subtract out our liabilities, and we're going to subtract out the other parts of equity, paid in capital, and our current year earnings, and that will get us to a good starting value for retained earnings. Just a simple way to get there very quickly of what, and with these starting values, what our starting retained earnings should be for 2032. And what you notice, because we kind of set it up this way, but now our total assets equal our total liabilities and equity. So we've got some good starting numbers there. Now going forward, we should be able to calculate what our retained earnings are for 2024 and beyond based on what was our retained earnings for the prior year plus whatever we earned that year, and that should equal our new retained earnings in theory. So let's drag that formula over. It's always whatever we started with in retained earnings the previous year plus our current year earnings. I've drug it over. Very good. Now then, we need to come back up here to our cash. The idea here is that the impact of our earnings, essentially the impact of any net changes here, that just fluctuates our cash balance. We're going to assume that accounts receivable, inventory, all the other things, debt, accounts payable, all that stays constant, and the only thing that that responds to earnings is, hey, if we made a lot of money, we add that to our cash balance. If we lost money, we remove that from our cash balance. It's a really simple way of modeling it out. So in order to do that, we'll do kind of similar to what we did with our retained earnings. We'll basically say, okay, well, our cash balance, that would be equal to whatever the total liabilities and equity were for that time period. So in this case, this cell. And we're going to subtract out. So our assets have to equal our liabilities plus equity. So if we start with our liabilities and equity, and then we just subtract all of our fixed assets, and then our other current assets, our accounts receivable and our inventory, that'll give us our cash balance. I'll right click, we'll just drag that over. And there we go. So if we see what happens here in 2024, we expect our starting balance in 2023, a cash balance of 150,000 to go up to 189,000. That is essentially a reflection of the 39,000 that we expect to make in 24,000. That's what gets us to that cash balance. All right, so we have a populated balance sheet here. We have a populated income statement here, and it's all for this scenario where we don't buy the putter company. All right, before we move on to the income statement and balance sheet in the change scenario, I want to update a few things. One being the interest rate on other assets. So this will be the interest rate that we earn on our cash. This is actually going to represent the interest rate that we pay on debt. I'll make that update. That'll pay 8% there. And now that we've established our balance sheet down here, we can come back up to interest earned and start populating these cells as well. So our interest earned would be a reflection of our cash balance, and we would multiply that by our interest rate that we expect on cash. I'm going to lock that in. There we go. We'll drag that across. We're getting an error here. about circular references. Okay, we want to think about whether, I think right now we're thinking our balance sheet kind of represents more beginning, or yeah, we'd have to establish whether it represents the beginning or the end of that year. What we'll do here for cash for interest earned for now, for simplicity, is we'll say it's a reflection, at least starting in 2024, of what your cash balance was the year prior. It'll be that times the interest rate on cash, and then we'll lock that in. Now we should be able to drag that to the right and do just fine. We'll take a similar approach for interest paid. So we'll start with what was the value on our balance sheet of our long-term debt. We're going to multiply that by the interest rate on debt, lock that in with F4 or dollar signs manually, enter, and again if we drag this across, oh, that actually does okay. But we could base this however we want. And the debt level we are expecting to stay at a pretty constant 100,000 below, so that's why it consistently assumes 8,000 paid in interest. Okay, so we've populated those. I'm going to center everything. Now I think we're ready to create our with investment scenario. Now a good place to start, we've done all this work to link all the cells together like they ought to be for an income statement versus a balance sheet. Let's go ahead and copy this entire section. We're gonna have to keep an eye on formula references when we do this. I'll go a few cells over, paste. I didn't do paste values. I want to keep the cell formulas in this case, and I'm going to call this our change scenario, or I guess our investment scenario. All right, let's take a look at what happened here. I just noticed this as I was copying. We probably want to widen column M, and we want to keep all the columns the same width, so we'll highlight all of the columns, just right click a little bit until we see those hashtags kind of go away. I suppose it's a good thing that by 2032 we expect our assets to grow in the millions. But there we go. Now we don't get that cut off anymore. Clearly there's something up over here. Probably didn't lock in cells like we were supposed to for certain ones. So let's see what happened here. I'm going to double click into sales, see what that's referencing. That was probably the issue. Yes, we did not lock in the sales reference, so we'll just go ahead and drag it over for now. And that way our starting balance is locked in. Very good. That took care of a lot of things, it looks like. Yeah, this is still referencing column D for cost of goods sold, gross profit, just still the difference between those two. Selling and general it's still referring to that same percentage in column D. Yeah, everything in the income statement is, oh, interest earned, there we go. Okay, so we're still referencing column D, but now we're referencing a cash balance of 0. So that's probably a reflection of the starting cash balance. We'll need to repoint that eventually. Same thing with debt, most likely. This formula looks fine, still referencing the same tax rate in column D, and income is a simple calculation. It drug over just fine. Go down to the current assets. Well, that formula looks good, but our cash, yes, our cash, the column moved over to column R. We could have locked this in perhaps. We'll just want to update that. Our starting cash reference to come over here to our 150,000. Good. Same thing with that one. Let's see, I think we can drag this down. Yep. And then similar with yeah, fixed assets, formula looks good there. Land, same issue as cash, needs to be drug over. We could have locked that one in. Land, we should be able to drag that down now. Good. These assets, sum of current assets, fixed assets, that looks good. Looks like we ran into the same issue with current liabilities. Wished I would have locked everything in before moving it over. But we'll fix that now. And then debt needs to be updated too, brought back to column D. There we go, it's looking good. Okay, paid in capital, that's another one that needs to be brought over. Really important to perform checks like we are right now. 361. You know, and a good check to make sure we didn't miss anything is just to check and see that, oh yeah, our assets are the same. Now we've been focusing on 2023 for now. Let's kind of scroll to the right and maybe we check this 1.037 thousand, 1,037,000 number. Now these are getting cut off over here too, so we'll do the same thing. Highlight the columns, drag to the right a little bit. Yes, that matches. I'm looking at 2032 after we've had all these years of sales growth and everything, assumed sales growth, and we're still getting the same balance. That's great, because right now we haven't really changed anything, but our model's set up. It's the links are there for our investment scenario, and so this is really good. We haven't changed anything. The investment scenario column matches the no change scenario. Now we're going to actually make some assumptions and change some things, and so we're going to, you know, write a few parameters here too, because maybe we're not sure how much this company's going to cost, and we want to get a sense for what the impact on our income statement and balance sheet would be at different investment levels, depending on what we pay for this company. So one of our inputs from an investment perspective, again, we're using a lot. You can see we're already using a lot of our starting parameters over here that are not necessarily going to change whether or not we make this investment. But there are some parameters that are going to be specific to the investment scenario, and so we'll mark those on this right side where we have the investment scenario. And the big one is going to be how much do we pay for it? What's the cost of the investment? And so we will start that at let's say 500,000, and we'll be able to adjust that if we want to and see what the impact is. Cost of investment. Now eventually we're going to have to think about how that gets allocated on our balance sheet. Let's say for this scenario that we're planning on financing that 500,000. This investment banker comes and they say, you know, we can help you get a loan for that 500,000. It'll just be additional debt, but man, it's going to be fine. You're going to be able to pay it off eventually because of all the revenue you're going to make. And so in the long term, it's going to be a good thing. That's the investment banker, let's say. Let me adjust this. And so if that's the case, then down here for our debt, what we'll do is say, okay, this equals actually what it did before, our starting debt, what it would have been, but now it's going to be that plus the cost of the company. There we go. All right, I'm going to move this over a little bit so cost of investment doesn't get cut off. Great, and we'll color this yellow. Now what we need to figure out is, okay, if your debt's going to go up, then your assets need to go up. So we need to figure out, okay, I paid 500,000 for something. What did I get for that? And let's just say the company, let's just say we say we got 250,000 worth of land, and we got 250,000 worth of equipment, and that's how this 500,000 is going to be allocated. Okay, so what we might do is say percentage of investment allocated to land, percentage of investment allocated to equipment. And we'll say it's 50-50 in this case. So about 250,000 allocated to each one. Let's see. All right, so here's our land. We're going to say whatever our land would have been, the 200,000, but now we're going to add to that the cost of the investment times 50%, the percentage allocated to land. And likewise, our equipment will be the 100,000 that we had originally plus cost of the investment times the percentage allocated to equipment. And so now, after buying it, we would have 450,000 in land, 350,000 in equipment. There we go. Looks good. We've got that parameterized. Oh, so if we want to update it later, we can. Now, let's say that as a result of buying this, we're going to expect higher sales. That would make sense. We're selling putters now. That's part of the purpose of buying it. Now let's say that we could do it from a percentage perspective. Let's say we expect an initial boost in 2023 when we buy the company. We're kind of assuming we buy it at the beginning of the year. Let's say we expect a boost of 125,000 in sales. That's our expectation. So see, impact, starting impact on sales. Again, we could do it from a percentage perspective. We'll say we expect to now have 125,000 more sales. That's about what the putting company was doing per year going into this. And we think there's some synergy here. We think that combining all of the putting and the driver, the total impact that'll have on our cost is it's going to reduce our cost of goods sold by 5%. So we need to factor that in as well. Impact to cost of goods sold. And the cool thing about this is if we want to update these and say, well, what would it be if we didn't assume that? We didn't make that assumption that it was going to lower our cost. We can change this to 0 and see how the model updates. All right, let's bake that in. So 125,000 is our starting impact on sales. So we would simply come down here. Right now it's referring to a starting sales in a no change scenario. We want to add to that this 125,000 that we get from the putter sales if we buy that company. Great. Now notice the rest of it, we're going to assume that 4% increase we were assuming before on our legacy sales as well as the putting sales now, and it goes up from there. So we are assuming that 4% on all sales with the putter sales included here. Then on our cost of goods sold here, we've got the sales, and I guess in this scenario we're assuming that that the putting company too had a 40% gross margin. We're subtracting out that cost of goods sold or that profit margin to get the 60%, but now we're actually saying that our costs are going to be 5% lower, and so we can come up here and subtract out that 5%. That will only help. Yeah, should have brought it down. Actually, I think we need to do, yeah, the impact is -5, so we need to add that. Always good to check your work and make sure it goes in the direction you thought it would. Oh boy. Okay, here we go. Okay, 1 minus 40%, add this, and it brings it down. Yes. Okay, good. So our cost of goods sold does indeed go down after factoring this impact to cost of goods sold, bringing it down by 5%. Okay, now we might need to, let's see if we need to drag things over here. Yes, this is one we'd want to drag over. It's consistently referencing sales. Before we do, we need to lock in the impact of cost of goods sold. That in, drag it across. Great. Okay. Well, let's just do a few checks here. Okay, so we updated our sales. We updated our cost of goods sold. Gross profit is still going to be the difference between sales and cost of goods sold. Selling, general, and administrative expenses. That is, we're going to assume that we pay the same 15% on our sales, even with the putter sales. And then earnings before taxes and actually that is something we might consider, is maybe we think we can keep about the same level of selling, general, administrative with the new company. You never know. But just different assumptions we can think about. And I just realized that these are not all centered. There we go. So I'd like them to be. Okay. Coming back to our formulas. Yeah, earnings before taxes and interest still going to be gross profit minus our selling, general, administrative cost. So that looks good. Interest earned. Okay, let's see what happens here. And this is part of where the analysis would come in. Just kind of look at it, especially for, yeah, notice in year 2025 it's a little different now. It's higher. The interest earned is higher. Let's go down here. We're referencing a higher cash balance here. So we expected our cash to go up in the year 2024. All right, now eventually we're going to go down to cash and kind of see if that amount still makes sense. Why would cash have gone up here? Well, let's come down here. Cash is really kind of a reflection of how much you earned. So our earnings, yes, we did expect more earnings in the first year, 2023, with the new scenario. We expected 43,000 instead of the 38,000. So that's about a $5,000 difference, which is also reflected up here. Why? How did we get this difference? Well, now we can kind of compare this 2023. We have 325,000 sales instead of the 200,000. Now our costs are higher, but you can see even after taking into account the cost, our gross profit is higher. Even after accounting for the selling, general, administrative, 15% of sales, our earnings before taxes and interest is higher. Then our interest earned is about the same. Ooh, look at this. Our if we didn't have to finance that, if we didn't have the big increase in interest paid because of, remember what this represents, it's that debt. Now it's 600,000 times the 8% instead of the 100,000 times the 5%. But what we're finding here is even after accounting for that higher debt service payment, this 48,000 versus the 8,000, 40,000 more in interest we're paying on that 500,000 that we borrowed to buy the company times the 8%. We're finding that the revenue that we got, or saw an expectation, we offset that, and then we're paying a little more in taxes because the earnings are a little higher. And at the end of the day, even in year one with that higher debt, we are making 43,000 instead of the 38,000. All right, very interesting. And so that allows us to coming back to, I think, interest earned here. We are starting to build up our cash balance by making more, which gets us more interest earned eventually too. All right. And we're consistently paying more on our interest paid, right? There at this point there hasn't been an assumption of paying back that loan at a certain point. But let's keep going here. So we have our taxes that fluctuate. It's always a reflection of what our earnings before taxes and interest our interest earned and interest paid were. And then coming down here, our current assets is always a sum of our 3 line items to make sense. We're not assuming any changes in accounts receivable or inventory. We assume this land and equipment purchase that was relatively constant. It increased when we bought the putting company and stayed flat from there. Same thing with depreciation. So our whole fixed assets is staying pretty constant. And our total assets is just similar to what it was in the no change scenario, just a reflection of our cash going up over time. Let's come back to that. Liabilities, we are assuming our current liabilities didn't really change, similar to the no change scenario, but our debt, instead of being 100,000 is 600,000, and that is linked to the cost that we paid for the company up here. So if we change that at the top, we can see how that would change below. Very good. And our total liabilities stay pretty constant. Same thing with paid in capital, not assuming that we're adding anything to the business. I guess we could have assumed that instead of financing it via debt by increasing our debt here by 500,000, that we actually paid in more capital. That would be another way to finance it. But in this case, we didn't pay in anymore. We're not taking out anymore. And we do see that our retained earnings is growing over time, and that's a reflection. It's actually growing more. If you notice here, our retained earnings in the year 2032 is higher than it was in the no change scenario. So we've got that captured there. Current year earnings, yep, that's higher. We saw that in the income statement. And our total equity, that has increased as well. And let's do that classic accounting check. Yes, our assets equal our liabilities plus equity. Very good. So we're kind of building up our cash balance here. We're able to build up some cash, and so what we might be able to do is we might be able to eventually take some cash and pay off that debt, so we don't have to pay that 8% interest rate anymore. Lots of considerations we want to consider. Can we invest that 8% and earn more than that 8%? That would determine on when we and how we would want to pay down that debt at a certain point. But an investment banker might now be able to point and say, here's what your income statement looks like today if you don't do anything. Here's what it would look like if you bought that putting company. For this scenario, there are a couple of selling points for the company to do this thing, and they would call this a leverage buyout because we're taking on debt to finance buying of a company. It's called a leverage buyout. But one selling point might be the fact that if we look 10 years from now at 2032, what we forecast to happen in the no change scenario versus the investment scenario, our equity, again, assets equals liabilities plus equity. So another way of thinking about equity could be if you took our assets in this section, in the no change scenario, our assets would be this 1 million or so. If we took those assets and we'd have to assume that this amount really represents what we could get out of it, and maybe that's maybe we need to reconsider that and think about depreciation and everything. But if we were to take those assets, subtract out all the money that we owe, accounts payable, deferred income, debt, we would be left with an equity amount. And you can see that the equity is assumed to go up. It'll go. We assume that the the total equity goes up from 922,000 is what we would expect to have 2032, 10 years from now. Without the change, we'd expect to have 1,063,000. So it goes up by, and we could actually copy and paste this whole table again and do the difference between the no change scenario and the change scenario year by year, and actually have a table that shows us what the forecasted difference would be for each balance sheet category for each forecasted year, and of course the income statement items as well. What would the true change be for doing this versus not? That might be worthwhile. But in this case, we just did this very quickly and said in 2032, our total equity, we expect that to be 141,000. So yes, you're taking on some more debt. Yes, that debt has 8% interest rate that you're going to have to pay year after year. But the revenue that you're getting, the cost savings that you're getting is worth it. And again, this kind of assumes that we took that 500,000, we assumed that we were really getting 250,000 in land, 250,000 in equipment and everything. And so that's part of it too. If we didn't actually get that, if we were to sell this whole company at a certain point and liquidate it, we would need to get those same values in order for this 141,000 to kind of hold true. So that's one way of kind of thinking about it at a very high level. Another route we might want to think about it from is it's not like a liquidating the company perspective, hopefully not thinking about that, but another route might be, well, eventually we want to take this money that we've made, this additional cash that we're seeing. So another look at it is, hey, your cash is going to increase. It's going to go from 647,000 estimated in 2032 to this 788,000 in 2032 if you buy the putting company. So you're going to have 141,000 more in cash. And you could use that cash to pay down the debt. And so maybe they get to a point just being very conservative about this decision and say, well, yeah, if 10 years from now we've earned enough cash to pay off the company, sure, we can do that. So at this point, if we were to say, well, we want to pay off that company in 2032, what we could do is say, okay, in 2032, our debt, I'm going to highlight this cell right here, we're going to subtract whatever we paid for the investment. Let's say this loan, kind of what we're assuming here is that the loan, it was just an interest-only loan, and so each year you saw the interest paid went up in the investment scenario. So we're paying that 8% on the 500,000. Let's say that balance holds true, and then at the end of 10 years, we're going to pay this off. So we subtract that. We're back down to the 100,000 that we were at without the investment. In 2032, we pay that off, and notice because of the way we've set up our cash is any of the changes that we make has an impact on cash. So what that would do to our cash balance in 2032 is bring it down to 319,000. And so it's lower than what it would be without the investment. But again, we have gained all of this. Hypothetically, we've gained land, right? We've gained 250,000 in land, 250,000 in equipment, assuming we can sell it for that, and our sales are operating at a higher level, and so we might continue to expect to get this higher net income that we've been observing. All right, so what we might want to do from there is say, oh, well, I'm just not, I get it. We still have higher equity to the tune of about 150,000 under this, because we can, if we were to liquidate the company, that would be our leftover amount in equity. But I really want to have the same cash balance in 2032 as I would without investing in this company. So they could say, okay, well, what if we invested, instead of the 500,000, let's say we invested 400,000. And now we can kind of compare and say, okay, that's a little better. our cash only goes down, our projected cash for 2032, it goes down by 170,000. What if we invested 300,000? Now notice, you might think, well man, you pay 100,000 less for it. Your cash balance then would be impacted by 100,000 less. Well, there's a lot more going on here. That invested amount impacts the interest that you're paying year after year after year, several other things as well. And so it's not as simple as just saying, well, if we pay 100,000 less, we'll have 100,000 more in cash at the end of 2032. Watch what happens if we pay 100,000 less than the 400,000 now. We'll pay 300,000 for the company. Now our projected cash delta goes from being down 170,000 to just being down about 11,000, which is fairly flat here. And that's because by paying less year after year after year, we were also paying less in interest too. And other aspects are probably changing here too. So if we can get this company for 300,000, and we could be a little bit more precise and maybe do, I don't know, 290,000 if we wanted to get this really close to zero. Okay, we pay 290,000. By 2032, we would actually project that our cash is the same level we had before, but our equity is significantly higher because we've gained all that land and we've gained the property, and let's see, what did we say? The equipment and the land has gone up by 500,000, and our sales are operating. Our net income now by the year 2032 is operating at a 45,000 or so net income each year instead of 24,000 per year. It's almost doubled our net income. And so, or I was looking at taxes, sorry about that. But actually, even if we look at the net income, our net income has gone from 134,000 to from 73,000 projected for 2032 to 134,000. That's a huge increase, and we probably project we could continue the projections here, project that continues to be the case, and in 10 years we're able to pay off that loan, the debt's gone, and our cash is the same. So maybe that's too rosy, maybe it's not, but at this point the investment banker is able to quickly adjust assumptions and say, well, how about this? Would you feel comfortable with this level investment? And they can make the offer to that putting company, see what happens from there. Hopefully you've enjoyed this as much as I have. It's really a great example of the way an investment banker or a company's investment team might consider a potential acquisition. All right, if you choose to accept it, I've got some homework assignments for you that you can use to reinforce the concepts that we've talked about today. The first one involves starting with our personal finance workbook. You can use the one that you've developed if you've created one alongside the training, or you can go to our website, check the description for the link, and download the workbook that I created there. And take that workbook, and on the second tab, create a second tab, and there we want to do a monthly breakdown, and we want to point it back to our first tab, our annual breakdown, so that if we ever update our annual budget, it would automatically flow through to the second tab. And it'll be broken down by month so that after each month we can actually assess, one, what our budget is, so make sure that it's by month what's your budgeted income and expenses. But what we want to do now is actually add in a column next to it, or at least some method of comparing what your budgeted amount was for each month to what your actual spend is. So come up with a second tab, breaks down your budget by month, and allows you to actually assess how you did that month in terms of income and in terms of expenses against what your forecast was. Love to see what you come up with, and maybe you can share a little bit about what you come up with in the comment section of this video. In the college football use case, we saw that the constant represented the impact of being the home team on the home team's point differential against the away team, but that was just for the postseason games. What I'd like for you to do is calculate that impact of being the home team on the home team's point differential, but for all games, not just the postseason games. So try to do that and let us know how it goes in the comment section. All right, last homework assignment, and this one also uses the college football games workbook. In the demo, we looked at the relationship between a simple winning percentage in the regular season and a team's postseason performance, and found there to be somewhat of a correlation. What I'd like for you to do is create a metric that assesses a team's regular season performance, but in a way that adjusts for that team's strength of schedule during the regular season. And then see if that metric that you create has a stronger or weaker correlation with the team's postseason performance than simply using the regular season winning percentage. We'd love to hear what you come up with in the comment section. I want to thank you for watching today. I know it's a time investment, but I hope you got a lot out of it. And if you did, please consider giving this video a like, and we hope we'll see you at our session 3 in the series on Power BI. Now, if you want to get notifications on when new videos like that one come available, please subscribe to our Value Driven Analytics channel. And let us know if Value Driven Analytics can help your organization with anything analytics related. Check out our website, valuedrivenanalytics.com, and if you're interested, give us a call, 1-877-825-3786 or 1-877-VALDRVN. We would love to talk to you.